Hi guys, greetings from Bulgaria. I am Anton, and in this video we are going to discuss the proxy and adapter design patterns. In this new course on the Lambda Test video channel, we are going to cover a lot more design patterns. First, we are going to see the proxy and adapter and how we can build a mini tiny test library or a framework as you wish to improve the maintainability and usability of our tests with the adapter. Then in the second module out of this course, we're going to discuss the decorator to help us add new functionality to our mini framework, like highlighting, scrolling to view, and for example, bringing toast messages without breaking the old code. Then in the third module, we're going to discuss different variations of the Singleton design pattern, ensuring that the class handler has only one instance while providing a global access point to this instance. This pattern helps us to improve the API usability of our test library. Then in the next module we are going to cover the dependency injection pattern to achieve loosely coupled architecture and enhance the test maintenance. We're going to use it to ease the creation of our page object models and other design patterns out of our mini library. The fifth video will be dedicated to chain of responsibility design pattern, and we are going to use it to create a sophisticated tool for troubleshooting exceptions that occur during the test execution. It will be quite interesting. Then we are going to cover the strategy design pattern. In our mini framework, we are going to add the possibility to easily add different ways for how you can locate different elements, improve the usability, and also we are going to do the same for waiting for elements. Of course, out of any automated testing solution, it's really important to handle properly the test data, so there will be two patterns dedicated to test data management, the repository and the factory, and even the last one, the builder, can be used for this purpose. However, we're going to use it for that as well, to create test data, but also we're going to create an easy way for doing layout testing, verifying the different elements where they are on the web page. Last but not least, we're going to cover the data-driven testing design pattern, that can, instead of copy-pasting different tests, we'll use MS test and NUnit and XUnit to use their attributes to handling this multiplication of the tests, and we're using the body for executing different test cases. If you haven't subscribed to the channel, please do so. Hit the ring bell so that you get notified about many awesome videos that are published each week on the YouTube channel of Lambda Test. Also check the awesome blog. There are many technical articles there that can help you to be a much better engineer. So, in this particular video, when we talk about proxy and adapter design patterns, first, of course, we are going to cover what is actually a design pattern. Then we're going to see a demo. First, initially, we're going to use vanilla WebDriver to just explain two different test cases. And then we're going to upgrade them with page objects. Of course, this is not the purpose of the video, so we're going quickly through the content. But we need to do that so that you can more easily understand the patterns when we upgrade them using the proxy and the adapter. So, first, what is a design pattern? We can define the design patterns as prescribed solution to everyday software challenges. They don't consist of code or any specific algorithm, but instead they describe how to group your logic smartly, how to reuse it, how to make it easier to maintain. It is basically a template for solving design problems, which we can use while we create our solutions. I know that this is a bit of more abstract explanation of what it is, but you can think of the design patterns as a template or as a formula that prescribes how we can solve particular challenges. For example, reusing our page objects without creating every time their instance using a singleton, or we can imagine that this test data management, test data creation is handling through factories. Now, let's discuss what is our problem. Again, for this purpose, we're going to use the Lambda test, my favorite demo website, the playground. And I created two tests here. The first of them is going to compare any number of products, and the second one is going to purchase them. So in our first case, we're going to type something here in the search. This autocomplete menu will appear. It appears in a few seconds. Then we're going to click on the product, and as you can see here, we have this compare this product button. So I'm going to add the first product, then I'm going to navigate again to the home page, type something else, add for example this refrigerator, and add it to compare list as well. And then our test is going to click on this compare button on the top, and when we click it, this table opens for us, and we need to verify whether the proper details about the products are displayed here. So this is our first test. Again, I'm not going to type it, I'm going to show you already written test, but just a few explanations here for the code. Of course, we find here the search input. If we zoom, we can find it by this placeholder or by the label. We can use XPath, as you know, when we press Ctrl F, and when we start typing, we can type input, and then we can say text or add placeholder, and we can type search for products. Here it is. This is the search. Then we're going to type something in it. And the tricky part here is when you type something, probably in our code we will need a hard-coded pause, since depending on the world on the website, this takes a few milliseconds up to 1 or 2 seconds to appear. And the second challenge is, as you can see, it's hard to inspect it, since it hides itself really fast. If you press Ctrl-Shift-P, and then if you type focused, we can click on that, and then this menu won't disappear. This makes our work for inspecting the different elements here easier. And the tricky part here in this particular locators is that we don't want to find the elements here by the title, since it won't be unique. But instead, if you take a closer look here, you will find that at the end of this URL, the anchor, the href, we have the product ID. So later during the course, we're going to talk about test data management, but in most cases, probably during using the database or APIs, we can create these data products ourselves using the APIs and be sure that it's there. We will know the product ID, so that using the product ID we can select that, and we can use string format or string interpolation to generate them. The second important part out of this test is how we are going to verify the data. I mean, the clicking of the buttons, etc., it's easy. It's not a problem. I mean, these buttons here, we can find it by label or by its text, or by the title, again using XPath. I don't think that this is an issue for us. However, here we can have multiple products, more than 2, and probably if we need to write this particular test, probably we need to make our test more general and be able to support more than 2. And in order to do that, we need to write complex locators. If we take a closer look, we will see that this is an HTML table, and we can select particular row, but by its label here. In order to do that, we can type table tbody tr, which is table row, td, and then we can select a particular TD, which is the cell, by its text. In our case, for example, imagine that we want the model, and here we selected the model. And next, depending on how many products you have added, we can select on the same row the next cells, and we can select them using XPath Access. If you are not familiar with XPath Access, there is an awesome article about XPath locators on the Lambda test blog. You can find it in the links below in the description. Also in the links below in the description you will find all of the source code that later I'm going to show you. There's one repository for adapter design pattern and one more for the proxy. And also you will find all the related articles. So if I type following sibling TD, after that I can select with an index the particular column that I want, and this is how we are going to write it in our code. So this is the first test. Let's see it and discuss the current structure. This is C# standard project. We use NUnit. Let me show you. There is a dedicated video series on the Lambda test channel about NUnit. I suggest you to check them if you are not familiar. But when you go and click Manage NuGet Packages, here NuGet packages are like Maven dependencies in Java. We use them to install all of the dependencies. In our case, for NUnit, we need these 4 packages: the Microsoft Test SDK, these 3 for NUnit, the analyzers, the NUnit, and the test adapter. Then we have 4 packages for Selenium. I added a few of them. The most important is the Selenium WebDriver, and for backward compatibility I added the WebDriver Manager. Since version 4.11 you don't need the WebDriver Manager, which is responsible for downloading the proper driver. Instead, the built-in Selenium Manager will be responsible for download the proper driver, and even now it includes browser management, which means that if you, for example, want to execute the test on Firefox and you don't have Firefox installed, it will download a portable version of it, and it will download the driver and then execute the tests. Again, you can download, it's already there. Also, yeah, I use the new syntax for global using so that I don't need to place them everywhere. So I added these usings in this usings class. I can remove some of them, and I can even move all of this as global usings as well. Also, for the namespaces, I use the new syntax where I don't need to nest them with curly brackets. So in this particular class, I oriented it with this test fixture attribute, which means that this is a test class. In the setup, which is the test init method, this will be executed before each test. We initialize the driver. I use WebDriver Manager to download the proper driver here, maximize the browser, navigate to the website, delete all of the cookies to clear any logins, etc. And this method, the teardown or the test cleanup, will be executed after each test, which means that this will close any sessions. If you use Lambda Test Cloud, basically you can put here all of the initializations. You can copy paste them from the capabilities generator. And here is our test. This is the test about the comparing products. I used here, instead of using many parameters in our private methods and method as a whole, I used the so-called POC objects or model classes, where in this case I have a special class here under the folder models, where it represents one product. We have properties about the name, about the ID, about the price, and any other information about this product. So I initialized 2 products here that I already know that they are on the site, the iPod and the iPod Shuffle, and I created basically 2 private methods here before we upgrade the version with page objects, just for simplicity. Let's review this compare product method. Basically, it's doing everything that I already explained. We are finding the search, we type the text there, then we find the specific item there by product ID. We use here string interpolation, which starts with this $sign, but as easy as that you can use string format if it's more familiar for you. If we use string interpolation, basically the thing that we want to format, in this case the product ID, we use these curly brackets. Then in this version we use hard-coded pause, which is a bad practice. We're going to upgrade it because, as I said, depending on the load, this will take a few seconds to appear. Then we click it, then we click compare this button, compare this product button. And the next important part is how we assert the products. Again, we need a hard-coded pause here. Again, we use this complex XPath that I explained, that it's built based on two things, based on the label. Probably we need to rename this parameter here to label. So this is the label, then we use 𝑣𝒏𝒐𝒏 sibling, and then we find the next column based on the product. And then it's easy, we just find the product name, the price, the model, the brand, the weight, depending on the particular column, and we verify them based on the expected product details. That's basically our test here. And our test case number 2 will be to purchase one product. Again, we are going to search for it, we are going to select it, we are going to increase the quantity, click add to cart, click view cart. In this simple version of this test, again, it's really simple because here you have hundreds of test cases to be checked, the different prices, variations, updates, remove, etc., multiple products, shipping taxes. However, in this simple version, we are going just to check that if we have 2, the proper total here is displayed. We're going to check out. Again, here on the next page, there are many branches of the tests, like, for example, we can log in, this will be pre-filled. We can use guest checkout. However, we are going to use the default branch of the logic where we are going to register a new account. We're going to fill all of the fields here. We're going again to check just the total, nothing more. Again, there are hundreds of test cases here. We're going to click the terms and conditions. Here the tricky part that we are going to do with JavaScript is that you need to scroll down, otherwise there will be an exception, and we are going to finish the order. That's basically the case, the test case. So I already implemented it. So again, we use this model class with the default information about iPod Touch. Again, we search for the product, we wait a bit, we click on it, then we increase the quantity. This is how we do it here with clear and send keys. Again, as you can see, there is a lot of repetition. In a minute we are going to fix it with page object models and the WebDriver wait for hiding some of the pauses. We click add to cart, then we wait, then we click view cart. We check the total. Again, as you can see here, again we use following signaling XPath access, and we have 2 more model classes about the user details and the billing that you can find under the models folder. And we have 2 important methods here. Few user details, really simple. We found all of the elements using ID, and we just typed everything from the user details mode. If you need to implement the rest of the branches, probably you need to implement other if-else statements or implement them as switch. The same happens for the few others form. And the last part is where, again, we check the total. And the tricky part, as I told you, is that we need to scroll to view to find this terms and agree button, otherwise you will see an exception. So we use this piece of JavaScript here. This will automatically scroll into view, and we complete the order. That's it. Now, how we can fix the hard-coded pausers, the thread slips, because this is a bad practice, right? There is a whole video about it, actually even 2 videos about thread slips, why it's not a good practice, another one about smart waits. Also, by the way, there is a really awesome smart wait feature in Lambda test. You can check the video as well if you don't want to worry about this, if you use mainly the Lambda test cloud. But anyway, the difference here between the 2 versions is that I implemented here the WebDriver wait class. We initialize it in the test init, and if we search for it here, you will notice that in a few places, instead of using directly driver find element, I use here this syntax: wait until expected conditions element exists, and I provided the biovocator. Basically, everywhere in most places, not all, but in 80% of the places, we were able to upgrade this solution, and this will automatically wait the necessary time for you the elements to appear. Also, don't forget to install this Selenium extras wait helpers NuGet package, because these expected conditions are part of it. So this was version 2. Now, version 3 is where I upgraded the solution. Instead of, as I told you, the compare functionality and the purchasing functionality, there are hundreds of test cases there, and we don't want to copy paste the code every time. Instead, we want to reuse it. And the pattern here to start with is, of course, the page object design pattern. There is a dedicated video about it on the Lambda test channel. I suggest you to check it. But for now, I'm just going to show you the version with it. In simple terms, what is the page object design pattern? For each web page part of your website, we have a special class about it, and there we put all of the elements so that we can reuse the vocators, and if there is a change in them, we can change it only there. And also we place all of the actions methods, and in some variations of it we put all of the assertions as well, so that we can reuse if there is a special logic there, or if there are any exception messages. Let's see them. You will notice that in my version here, it's really simple. I have a base class called webpage. It's really simple, abstract base class where we are going just to reuse the driver, the wait, and the actions class. And here we have protected variables for them. And then each page object is going to derive from this class. And here, this is why we call their base constructor. Then each page, all of the elements are present as public properties. Again, depending on the variation of the pattern, these properties can be fields, they can be private. It depends what you want to achieve. Here I just wrapped all of the elements as public properties, and you will notice that not everywhere I reused and put here the calls to this whether the element is visible or whether it exists there. In other places we just call driver find elements. Maybe if you use the base class, you can put this in a protected method part of the base class. It's up to you. And then next I moved basically all of the actions here inside this page object. That's all, and also the assertions. This is my preferred way. And the big difference here is that we're not only reusing the code, but we're building the so-called DSL, domain specific language, which later in a minute, when we see the refactor test, you will notice that basically our test is reading like sentences. It makes our test much more readable, because basically this DSL, domain specific language, we don't care about the specifics here. You're going to care them only when you develop the page object, or later when you want to maintain them or fix them to accommodate new requirements. We don't care how we wait, for example, whether we call JavaScript here or not. Really, when you open the test, you will notice that again, we have only the range phase where we care about what is our test data, because this is important for you to understand what is the real test case. And then here, it's really much shorter, much more readable. We see just the scenario that we want to automate. And during the DSL, we find what we are doing here, right? Now, and lastly, here in this version, we have this common basically class that initializes all of the pages instead of repeating this everywhere inside of our tests. Later, if you change, for example, the base constructor of all page objects, we can upgrade this, we can refactor it just in a single place. And it's much easier to find all of the web pages instead of wondering whether we have particular page or not. Later, if you want to give access to your users to the page, you're going to add it to this website class. That's all. Now, let's review the proxy class. I added a diagram to our presentation here, and let's discuss the proxy. Again, the proxy is a simplified version of the adapter. Actually, it provides a surrogate or a placeholder for another object to control access to it. In our case, this will be our iWeb driver or iWeb element. We are going to use another principle in object-oriented programming languages. It's called composition, and many people prefer it instead of using directly base classes or the so-called inheritance in object-oriented programming. In our case, the proxy, how it will help us is that it's going to basically hide the complexity of using all of these WebDriver waits and how we wait for the elements and everything. We can directly put this logic inside our custom implementation of the proxy here. We are going to wait for the elements here. If you want to, for example, click on the element, we can, for example, wait for the elements to be clickable. If we want every time to scroll into view, we can put this logic also here inside the implementation of the proxy. So let's see again. There are two repositories that you can find in the description below. The first one will be about the proxy. So really simple here is the implementation of the proxy. The really important part here is that we are implementing the so-called subject. In our case, the subject is the iWeb driver. This is basically the two proxies. The first one is going to implement the iWeb driver, which means that we'll have to implement all of the method part of this interface. If we open it with if we click and go to the definition, basically we need to implement all of this. Let me show you. We need to implement this pause, close, quit, manage, navigate, switch, URL, title, page source, all of the methods part of this interface. And as I said, we're using composition. The composition principle in object-oriented programming languages is where classes should achieve polymorphic behavior and code reuse by their composition or by containing an instances of other classes that implement the desired functionality. In our case, this is the iWeb driver and the WebDriver wait. And we achieve that with coding these references instead of using inheritance from a base or parent class. And this is especially important in languages like C# and Java, where multiple inheritance is not allowed. So, as I said, here in this version, we do two things. In our find element, you will notice that we use the WebDriver wait here instead of driver find. This means that every time when we call our WebDriver proxy implementation, we are going to wait for the element to exist. And we're going to return, as you can see, this web element proxy. In a minute we are going to see it, but it implements iWeb element, so it's fine. We're going to return it here. But in reality, every time here again, when you call, for example, to search inside another element, we are going again to wait for it. We can add again. When you want to click it, we can wait for the element to be clickable, then to click it. And we did the same for the finds element. And if we look into the web element proxy, basically this is the implementation of the pattern. We need to implement the actual interface. This is how we don't need to change anything in our pages, nothing more really. The only difference here is that in our tests, when we create the Chrome driver, instead of initializing it directly to the iWeb driver, to the iWeb driver that we're going to use in our pages, we're going to assign the WebDriver proxy. And that's fine, because the WebDriver proxy is the implementation of the iWeb driver interface. And behind the scenes, it's going, when you call find, it's going to wait every time. We basically hide all of those complexities. But again, as you can see here in the web element proxy, the big difference is that every time we wait for the element to be clickable, and when we search for elements, we wait for them to exist. Otherwise, we're just calling the internal element here, or the actual subject that we use using the composition principle. However, the big problem here is that you're implementing basically the same interface. We cannot add new methods like wait for Ajax or others. We cannot improve the interface. For example, if you don't like the same keys that it's used for multiple things, we cannot change it for example, a method called type text. Or anyway, and we can solve all those challenges using the adapter design pattern. So let's review the adapter design pattern. Here is the diagram. It's a little bit more complex, but not really. I mean, it's just this is why I choose to first show you the proxy and then the adapter. So it can help us to eliminate these usages of hard-coded pauses in our automated tests. And again, we're going to use again these explicit waits, but also we're going to add new methods like wait until ready, wait for Angular, wait for Ajax. We can improve the interfaces, and these improved interfaces are here. This is called a target, and this target, it's basically the actual implementation of this target interface is this adapter, which is used to adapt the adaptee interface. In our case, this is iWeb driver and the iWeb element. Basically, this new interface defines, you know, how from now on we are going to use in our page objects or in our tests the driver and the actual iWeb element. In order not to confuse them, I renamed our interface. Instead of using iElement or iWeb element, not to confuse it with the original iWeb element that comes from Selenium, I called it iComponent. And as you will notice, the new methods here, instead of using find element, we have now find component. And the big improvement here in this mini library is that now our components or web elements, they know how they were found. They have an instance to the bilocator that they were located by. Also, they have now, instead of send keys, they have this type text. Also, they have a new method called hover, and we can hover now. We can later add other methods like focus. Also, we have an instance, a public property, to the wrapped element that we are going to use again through composition. And here in the driver interface, we added two new methods, wait for Ajax and component exists. Also, we deleted some of the methods that we are not going to use, And these find component methods, instead of find element, they are going to return actually the component adapter or the actual implementation of these new interfaces. So let's review now the adapter. Now in our page objects, the difference is that instead of the 𝐴𝑤𝒏𝒕𝒐𝒏 interface and the usage of 𝐴𝑤𝒏 element, now we are going to use the two new interfaces here. This is the big difference now. Also, the another difference is that now, instead of calling find element, I'm using this find component. And of course, everywhere, instead of send keys and calling clear, I'm going to use this type text. Let's review quickly the new interface. This is the new iDriver interface of the adapter. We have the URL. Also, I have a new, I forgot about this, but we have a new method called start. This is called a factory method, and we are going to use it to initialize the driver based on this enumeration about the browser itself. Basically we discussed all of this. The 𝐴𝐿_component, as I said, the important part is this public by property, how the element was located. We have the type text, the click, and of course the modified version of the find element methods, in this case find component. And let's review quickly the actual implementation. So the driver adapter, this is our adapter class, which is similar to the proxy class that we discussed, but now instead of implementing the 𝐴𝑤𝒏 driver interface, now we're implementing our brand new iDriver interface. And again, through composition principle, instead of using inheritance, we're holding these two private variables instances to the 𝐴𝑤𝒏 driver and 𝑣𝒏 driver weight. We have this brand new factory method for starting the browser. Basically, we moved here all of the logic for the 𝑣𝒏_driver manager. As I said, this is just for backward compatibility. Otherwise, this will happen automatically for you in the new versions of Selenium. And if we navigate to the find component, you will notice that here, again, like in the proxy, we use the 𝑣𝒏_driver wait to wait for the element to exist. This is the native web element found by 𝑣𝒏_driver. And then instead of initializing a proxy, we are initializing the new component driver that implements the 𝐴𝐿_component interface. And we are providing all of its dependencies. In this case, the 𝑣𝒏_driver, the native web element, and the locator, so that we can initialize the by property. We can add other logic here as well. By the way, this is one of the drawbacks of this pattern, that it's not easy to extend. And later we'll fix this problem in the next course out of this module, when we discuss the decorator design pattern. Instead of adding new logic here to the find component, we're going to see how we can use the decorators to extend this without modifying our core logic of our test library. But yeah, here we can scroll into view, we can highlight, we can add new logic. Again, this can bring some regression to our test. This is why I prefer the decorators instead. So for the find components, we're doing the same. We're waiting for all the elements to be present, then we're for eaching them, we're creating all of the components here, adding to the list, and then we're returning the same list. We have new method, like, as I said, this is the main benefit of the adapter design pattern. We added these brand new methods, like the start and then component to exist. We can wait, and we can use this new by property of the component, where we can wait until the component is there. We have this new wait for AJAX functionality, where we are using the 𝑣𝒏_driver wait to execute this script and wait for all of this asynchronous JavaScript requests to finish. And the actual implementation of the component, this is the component adapter. Again, instead of implementing the 𝐴𝑤𝒏 element, now we're implementing the 𝐴𝐿_component and using the composition we are holding references to everything that we need. In this case, this is WebDriver, the actions, the IWeb element, this is the element that we found, how it was located. In most places, probably you are going to return directly the native element and its properties. However, we changed the actual interface of the IWeb element, and now when you call click, you can instruct your mini framework, mini library, whether you want for the element, for the library to wait for the element to be clickable, and then we can click it. Also, instead of using this syntax everywhere, clear and then send keys, we have this brand new type text. We have a brand new hover method that inside, instead of repeating all of those methods here, we can just call hover, and this will use the actions class to hover our element. We have internal methods like wait to be clickable, and of course the find component that it's returning our brand new interface. And if we look into our tests, again, instead of using the iWebDriver interface, now we use the iDriver. Now we use the new start method to initialize everything inside, and then we're just passing the driver interface. From there, anything else stays the same. Again, the difference is inside our page objects, where instead of using iWebDriver and iWeb element, we use our two modified interfaces of our adapters, where we adapted them. Again, there is this cons of this pattern. If you don't need to extend it in the future, then pick it. It's really simpler compared to other patterns like decorators or observers, but it's powerful enough to help you solve our challenges. In this course, out of this module about design patterns, we covered the proxy and the adapter design patterns that can help us to create this mini test library to make our tests more maintainable, more readable, more usable. In the next part out of this course, we are going to discuss the decorator design pattern that can help us further improve these patterns, where we can add new logic to our mini library without causing any regression or any other problems. Thank you for watching. If you have any questions, put them in the comments below. I will be really glad to hear your opinion. Don't forget to get your free certification. Check the Lambda test blog. And yeah, see you in the next video. Thank you. Hi guys, greetings from Bulgaria. I'm Anton, and in this video we are going to discuss the decorator design pattern. So, in this course we're talking about design patterns. In the first video we were talking about proxy and adapter patterns that help us to create much more flexible mini test libraries, changing a little bit the interface of iWebDriver and iWeb element, and help us to build much more readable and maintainable tests. In this video we are going to extend on these concepts and discuss the decorator that will add the possibility to add new functionalities to objects dynamically without altering their structure. For example, we are going to add to our mini library easily highlighting, toss messages, logging, and scrolling to view. So stay tuned, it will be quite interesting. In the third video we are going to discuss another popular and quite useful pattern in automated testing, the Singleton, that ensures a class has only one instance while providing a global access point to this instance. And this is really helpful integrating with other design patterns like factory, repository, facades, page object models, and others. In the next video we are going to discuss the dependency injection pattern to achieve a loosely coupled architecture and enhance the test maintenance. After that, we'll delve into the chain of responsibility pattern to pass requests a chain of handlers, improving flexibility and object interconnection. There we're going to build a tool for troubleshooting tests, while we'll have different handlers for displaying the proper message based on the troubleshooting. Then we'll discuss and master the strategy pattern to define a family of algorithms, encapsulating each one and make them interchangeable. We're going to extend our mini test library for being able to extend it with different finding strategies and weighting strategies. Of course, it's really important for every test automation solution to have a proper test data management. Thus, we're going to talk about 3 related patterns: repository, factory, and builder. We're going to use them to create test data using APIs, databases, and create these model classes that we are talking in many videos. And of course, when we come to the builder pattern, we're going to look into a solution that can help us to facilitate layout testing more easily. And in the last video part of this course, we're going to discuss the data-driven testing, that it's really important in C# and Java and other languages, so that we don't need to copy-paste tests, but reuse the body of the test, but execute it with different set of test data. And we're going to discuss different test frameworks in C#, like MS-test, NUnit, and XUnit, how they do that. And we're going to check the most important attributes. So, if you haven't subscribed to the channel, please do so. Hit the ring bell so that you get notified when new videos are published. Each week there are many awesome videos. Also, don't forget to check the Lambda test blog. There are many detailed articles about a lot of the stuff that we are talking about in these courses. And in the show notes you will find links to the GitHub repo about the patterns, and links to other helpful videos and articles out of the Lambda test blog. So, before we begin, of course, we are going to first discuss what is a design pattern. Then we're going to define our problem, but more quickly. I already prepared all of the code, so I will really quickly explain it to you. But it's really important to notice that we are not going to oversimplify, because if your problem is simple, then probably you don't need to use design patterns, but we use design patterns to solve more complex problems. Thus, I created 2 middle complexity tests using the Lambda test demo website that we are going to refactor using these design patterns. And of course, we are going to discuss the decorator. And if you have missed the video about adapter and proxy, I suggest to check it. Again, I will try not to connect the logic between the 2 videos. I will give you, even if you haven't watched it, for a few minutes, I will give you a brief overview about the adapter and the proxy, because they're connected to the decorator. So first, what is as a design pattern? We can define the design patterns as prescribed solutions to every software challenges, everyday software challenges. They don't consist of code or any specified algorithm, but instead they describe how to group your logic smartly, reuse it, or make it easier to maintain. It is a template for solving design problems, which we can use while we create our software solutions. In the adapter, in the proxy, and in the decorator, we use other object-oriented programming principles, such as composition. And you know, in this principle suggests that the classes should achieve polymorphic behavior and code reuse by their composition, meaning that we have private variables to those classes instead of using inheritance. We'll use this a lot, and this is especially important like in languages like C#, Java, where multiple class inheritance is not allowed. And by containing instances of other classes that implement the desired functionality rather than inheritance from a base class or parent class, this is like a suggested approach in such languages. So let's define quickly the problem. Again, you can download the full source code out of the GitHub repo link below. I'm going to use again the e-commerce playground website, an excellent demo website. If you haven't played with it, I suggest to do so. Our first case that we're going to check is how we are going to compare two or more products. In this particular solution, first I'm going to show you the code with vanilla WebDriver. Again, I'm not going to code anything, but just explain really quick the code. Then I have an upgraded solution directly that I'm going to show you with the adapter pattern, and we use their page objects. If you're not familiar with page objects or explicit weights that we are going to use inside the adapter, I suggest to check the relevant blog articles, and there are a few videos that I have recorded in the past on the Lambda Test channel that can be useful. So here is the problem. We can type a name of the product, then we can select it from here, then the detailed page will open, and as in any eShop, we want to compare that. So we are going to click this link, and we are going to repeat this a couple of times for different products. So we can add this product. I will just emphasize two important parts out of this case. When we open Developer Tools with F12, you will notice that this disappears here, the autocomplete. If you don't want, and in order to be able to inspect the different links, we can press Ctrl-Shift-P and then type focused, and we are going to emulate a focus page. Now, when I search, I will be able to inspect those elements without this autocomplete to disappear. The first thing to notice here is that when in order this autocomplete menu to appear, it requires additional JavaScript requests to the server. This means that sometimes this may be slower, and the initial version of the tests I put there hard-coded sleeps, which is of course a bad practice, and thus we use explicit waits for waiting for the element to exist or to be visible. But again, in the best case scenario, we want to hide those complexities there. So another important thing here is how we locate the products. The first thing to notice here is that you cannot rely that the name will be unique. Thus, here, if you notice, there is a product ID 32. We can find this anchor using such XPath that contains, the href contains this product ID. When we discuss the patterns about test data creation and management, I'm going to explain how we can create such products or entities using APIs. But besides that, we accept that we're controlling what products we have. We know the IDs, and we're going to select them by ID. So this is the first important part about this test. And then when we add a second product, here is easy. We just click the buttons, etc. The next part is to click this compare button, and then another challenge in this particular test is how to verify the information for all of the products, right? And as you can see, this is one big table. If we inspect it, you will notice that this is actually a table that has a T-body. We have TR, which stands for table row, and then we have these cells. You will notice that first we have this label. This is the unique thing. And then we have the information about the two products. But again, as I said, there might be more than two. In order to locate them, when you press Ctrl F inside the dev tools, we can write and use XPath access to, we'll have two parameters. The first one is the label, which is price, model, brand, and the next one is the column index. This is column index 1, column index 2, and if you have more, we can introduce them. So let's type that T-body, TR, TD, which is the cell, then square brackets, and we can use text method, and I can provide, for example, model. As you can see, we selected the label, and now we want to select the item just below. We can do that using XPath access. Again, there is a detailed article about XPath locators on the Lambda test blog. I suggest to check it. And we can use following sibling. The following sibling is the one that it's just below the one we selected. We use 2 dots, and then I can say TD, and as you saw, we selected the first column after the label, and if I want the second, as I said, the second parameter will be this index. So basically these are the 2 important parts out of this test case. And the second one is about purchasing the product. So I can type again something. I will select it again using the product ID, and then imagine that we want to change the quantity here and add it to cart. And then I'm going to click view cart. Easy, just locators for the buttons. There are hundreds of test cases here that we can check, like multiple products, increasing the quantity, updating it, deleting it. Then there are many prices here to check, especially with the coupons, certificates, and shipping. Again, we won't do that. We'll just verify the total. We'll keep it simple. And then when I go to the checkout, again, there are different branches, many different cases here with the prices. We'll check just the total, and we'll basically we'll choose the default workflow here with the registering an account. We'll just fill the data. We'll select here terms and condition and finish the order. That's it. Again, the most basic 𝐵𝒏𝒕𝒐𝒏 scenario. The tricky part here is that in order to click here the terms and conditions, we need to scroll down. Otherwise, if you try to click it immediately, this will fail. And you will see that we do that with JavaScript. This is called scroll into view. There is a special JavaScript function, and this will be one of the extensions that we'll do with the decorator design pattern. This is especially useful when, for example, you execute your test in the Lambda test cloud, or if you have your custom solution for video recording. Many often, instead of viewing this part, but the actions are below, it's much better for you to use this particular solution when it's scrolled, because you're going to see where the action is happening, right, in the video. Otherwise, it will be hidden from you, and you must rely on full page screenshots. So these are the 2 cases. Now I'm directly going to show you the first. Let's see the solution with the C#. Again, you can download the full source code from the links below. I used standard NUnit setup. If you're not familiar with NUnit, there is a dedicated course on the Lambda test YouTube channel. Check it out. But this is standard C# setup. We use the latest .NET 7.8 version of the framework. Also, clicking on manage NuGet packages, I installed everything necessary. We have 4 necessary packages for NUnit. This is the one from Microsoft, and then we have 3 packages for NUnit, which is the testing library. And the most important, of course, dependency is the Selenium WebDriver. The other, I added them for backward compatibility, especially the WebDriver Manager. From version 4.11, we don't need WebDriver Manager, since Selenium is using their now native Selenium manager that it's responsible for downloading the proper driver based on your browser versions. Anyhow, I picked it up here for backward compatibility. Then we have these tests. I'm using the latest C# features, like for example the namespace. I don't use curly brackets, and also I use global usings. Here we decorated this class with the attribute test feature, which means that we have test there. In the setup or the so-called test init, we are initializing every time the driver. This setup is executed before each test. If you are, so here we are starting the browser, we are navigating, we are deleting the cookies. If you want to execute your test in the Lambda test cloud, this is the place where we are going to put all the capabilities from the generator. Then every time we are deleting the we are closing the session after each test, and this is our first test. We have two products here. You will notice that instead of using many parameters, I'm providing the data using model classes or the so-called POC objects. They're just simple classes that contains only string and integer properties that contain information about the product, like the name, the ID, the price, the model, the brand. You can extend them if you wish. And I initialize them, as I said, with well-known products that are on this particular environment. In many cases, if they are non-existent, we are going to create them later with other patterns like repository. So I created here two private methods, one for comparing the products. As I said, we are finding the search. Then from the drop-down, as I said, we are using string interpolation to format the proper XPath here. You can use string format as well. It doesn't matter. This is just shorter and much clearer to read. Here, this is not improved solution where we use hard-coded pauses, but again, there is a second version here that we used explicit waits with WebDriver wait. But in a minute, I'm going to show you the solution that basically is hiding all of those nitty-gritty details about how we wait, etc. And the next big important part is about the table that I showed you how we verify. Here we're building this complex locator that I told you about, the label in the column. And basically when we find all of the columns based on these labels, we are verifying that the information is the right one. And after that, we have the purchase test case, where again we have this model class with the product that we want to buy. We're searching for it, we're adding it to the cart, we're increasing the quantity, etc, etc. We are verifying the price. Then we have two other model classes for the user data and the billing info, and we have two other private methods for filling the information inside all of those inputs. And again, if you have more branches here about the login and already created account, we need just to extend the solution here with other switches or if-else clauses. Pretty simple. Here we are finding all the elements with using their ID. And the trickiest part here, as I said, is that we are using JavaScript to scroll to the terms and agree button, and then we are clicking it, otherwise this will fail. That's all. Now, if I need to quickly tell you about the adapter, the biggest difference about the adapter is that it helps us to let me first actually show you this is the proxy. The proxy is simple. For the proxy, we're implementing the same interface, the iWebDriver, and the only thing that we changed in the WebDriver proxy class is how we locate the elements. Basically here, I added the WebDriver wait, explicit wait, so that we know that when the element is returned, we can remove everywhere the pauses. Let me quickly show you this solution. Here is the proxy. So this is the proxy. As I said, we are implementing the same interface. We're using composition, meaning that we have a private variable here that we initialize in the constructor. And everywhere inside the find elements, we are referring to this driver, right? We have a similar proxy for the web element, but the biggest difference here again and change and the improvement is that when you call find element, we are going to wait directly. And when we look into the tests, they're the same tests, the same pages, right? The same iWeb element, the same driver, nothing changed, no different methods, no different signature. Yeah, one more thing, I implemented here the page object pattern. For those of you that are not familiar, basically maybe this is the most popular pattern in automated testing out there. We have special classes for each particular web page, for example for the home page, the checkout, the cart, etc. compare screen. And in this particular class, we are putting all of the elements right here and how we find them. The biggest benefit here is that if we need to change the locator, we do it in a single place. And then the next thing is that we, instead of directly like here in the test class, putting all of those private methods and having all of those details here, how we scroll, we put everything inside these pages, right? All of those methods are here. This makes the maintenance much better. It's improving it, because if we make changes to the workflow, we are going to do it in a single place. And also this makes our test more readable and shorter. And we are hiding all of those complexities for, if you try to understand the test, you don't want to parse unnecessary code. And there are different variations of the pattern. For example, you can sometimes hide all of those elements to be private, or you can put assertions here or not. It depends on the variation. I prefer to put the assertions here because sometimes they're more complex, sometimes they have exception messages, etc. I created a base page to reuse some logic here, and basically that's it. As you can see here, this is much shorter because we know on which page we are and what we do. This is called a DSL, or domain specific language. This really improves the readability. So this is the proxy. Now, if we look into adapter, as you can see, it has much more parts. But anyhow, if I need to summarize it really quickly, without explaining everything that I did in the previous module out of the course, again, we are using composition. We hold a reference to the 𝐴𝑤𝒏 and to the 𝐴𝑤𝒏 element. However, we updated and changed their interfaces. We adapted them. We added new logic to them. For example, right now I changed the signature. Instead of having a find element, now I have a method called find component. I added a new method, wait for Ajax. I also added a new method that you're going to see that it's called start. We added this new method, component exists. Now my component, or I rename it to component not to confuse it with the 𝐴𝑤𝒏 element, right? So my component, or the actual element that we find on the page, it contains a reference to the native 𝐴𝑤𝒏 element, but also it knows now how it was located. It contains a property to the bilocator. And again, we changed a little bit the signature of some logic. For example, instead of calling every time clear and send keys, which is weird method name, now we have this type text. And we have this new hover method. And so when we have these two new interfaces, instead of having this proxy class, now we have adapter. This adapter basically implements the new interface, contains a reference to the 𝐴𝑤𝒏 driver, and we are basically implementing this interface and adding new methods. We are doing the same about the component. And in the test, instead of using 𝐴𝑤𝒏 driver and 𝐴𝑤𝒏 element, we're using now 𝐴driver and 𝐴component. Here is really quick. This is the 𝐴driver interface. As I said, we have this new start method. We have the find component, where we are again waiting for the element to exist. We have wait for Ajax for removing completely all of the hard-coded pauses there. And here is the 𝐴component. We have the bilocator, the wrapped element, the type. And if we look into the actual implementation about the component, again, we are using composition. We have a reference to the actual 𝐴𝑤𝒏 element, the actual 𝐴𝑤𝒏 driver, and we are assigning them through the constructor. And we have a modified version of the click where you can, via this Boolean parameter, you can say, please wait for the element to be clickable instead of throwing exceptions, right? So yeah, and if we look into the actual implementation of the driver adapter, as I said, here we have this so-called factory method. We are going to talk about factories in the next module, but yeah, basically we use this method to initialize the proper driver based on this enumeration that holds different browser versions, different browser types. And in the find component, instead of returning iWeb element, we are returning the iComponent. The biggest drawback, and now we'll start talking about the decorator, is that if you want to add new functionality to this core logic here, the biggest problem is that we need to directly update our main logic here, and this will break some of the solid programming principles. For example, one of them is that our classes should be open for extension but closed for modification. Why is that? And this is really important, like principle, because if we do that and if you change it, it's really possible to cause a regression or a problem in many other tests or code, and thus we don't want to make really big updates to our main logic, but instead using other classes, adding on top of it to add this new logic. For example, highlighting elements, or implementing this automatic scroll into view, right? So with the decorator, we are going to do that. And as I said, the big difference here in the page objects, and it will be the same with the decorator, is that instead of using iWeb driver and returning iWeb element, everywhere we're just using iDriver and iComponent. That's it. And in the tests, they're absolutely the same, like with the proxy. However, instead, again, we are using the driver adapter. That's it. Now, let's review how we are going to change that using the decorator, how we are going to add this new behavior without modifying the main logic. Now, we have the driver adapter. I mean, in the actual decorator pattern, this sometimes is called a concrete component. Don't confuse it with our components and the elements. This is why this particular class in the code that I'm going to show you, I called it web core driver, because in the pattern, it's, even when it seems to be and very similar to the adapter, it's not. But anyway, so this decorator pattern, again, it attaches additional responsibilities to an object dynamically. Decorators, they provide this flexibility, flexible alternative to subclasses for extending functionality. And you can wrap a component with any number of decorators, as you are going to see. We are going to develop four such decorators. One for highlighting, scrolling into view, toast messages, and one for logging on the console. And you can change the behavior of its component by adding this new functionality before and after the component methods. For example, before calling the find element or find component method, or after it. It will be up to you. So basically, these two parts, they stay the same. We have the interface, or in this particular case, I'm going to show you alternative implementation using abstract classes. It doesn't matter, you can do it with interfaces again. However, I'm going to show you the second version using abstract classes. So we have the same interface or an abstract class that defines the new methods. We have the same implementation here, adapter or whatever word you want to call. Again, usually this is called a component, and this is the concrete component in this particular pattern. And then the biggest difference here is that we have this driver decorator class. Again, we use composition to hold a reference to the interface of the abstract class, the iDriver. Then we have implementation of all of the methods, but we don't add anything new here. We are just calling through the composition the driver, and we are referring to its methods. And we do that because sometimes we don't want to extend all of the methods and add new logic to them. Sometimes, like in the case with the highlight decorator, we're going to extend the particular driver just in 2 points, the find component and find components methods. However, other decorators like the 𝑨𝒏𝒕𝒐𝒏, we're going to add the 𝑨𝒏𝒏𝒕𝒐𝒏 to all of the methods, but it will be up to you. And this will be fine because this class, it extends this one that's basically already implemented everything from here. And this way we can say that we are just reusing some of the code. We are not, you know, copy pasting the same methods that are repeating the code. That's all. Let's see it in action. I mean, it's not so hard. Again, we have the same cases here. We have the same page objects. You will notice that, again, as I said, instead of having the iDriver interface, this time I implemented this as an abstract class. This is why the I here is missing, but that's the only difference. The same for the component. If we look into the driver abstract class, again, this is one-to-one to the interface that I showed you about the iDriver. Again, it's up to you whether you're going to use abstract class or the interface. In this particular case, maybe it's fine to use just interfaces. The big difference here is that this time I'm instead of the keyword interface here, I have abstract class, and everywhere I need to use the keyword abstract. The second big change in the implementation now is that when we look into the web core driver, this is the alternative of our driver adapter. It's one-to-one. This time here we since this is an abstract class, we need to use the keyword override, right, in order to implement it. But besides that, everything here is absolutely the same. The actual implementation of and the alternative to the component adapter, now I named it web component so that we don't confuse the two patterns. And here again, instead of iComponent, I have the component abstract class. But again, the same logic. We are waiting for the element to exist. We are just initializing it. And another big difference here for the components is how we decorate them here with the web component, but we'll get to there. Let's see the easiest example with the driver decorator first. So as I said, if we come back to this diagram, the new thing here is that now we need to have this base class, the driver decorator. This is the thing that I'm going to show you now. So this abstract class, the driver decorator, it will be the base class for all of these decorators that are going to add new logic to our web core driver or to our adapter, if you wish. Pretty much, if you look closely to it, do you remind you of something? It's actually direct implementation of the proxy design pattern. Again, let's not confuse them, but in reality it's just that. We are implementing the same abstract class or an interface, and we are using composition, and then we are just referring to the composite object, in this case the driver. However, as I said, this base class, the only purpose is to call the same method here, and the only reason for doing that is that when we actually create a child class out of it, now we won't need to implement all of those methods again. And for example, if you're not going to extend them, otherwise you're going to copy paste this 4 times. But now we are going to reuse that every time when we derive from this base class. Now let's see the highlight. How we do the highlight. I'm creating a child class that derives from this driver decorator base class. In the base constructor, we are providing the same driver in order to be able to create this type of nesting for the decorators. And as I said, we can override only the methods that we want to extend, because the rest of them are implemented already here in the base class. This is its primary reason. And what does it mean to have this highlight? Let's run the test and I'm going to explain. We will implement 4 of them. We will have the highlight, which will be when the tests run, you will notice that we have this yellow background on some of the fields that we are doing something against them. Then we'll have a logging where, for example, when we execute the test here, we'll have this console log. Here we'll create this console log where we'll know how the element was located, etc, etc. We'll have this scroll into view to scroll exactly to where the action is happening, and we'll have these toss messages that pop up from the left corner. Let's run one test and you're going to see what we are doing. Let's execute this particular test. It takes a while to build the project, and now we have here Chrome. You'll notice the yellow, and observe in the left right corner these blue boxes are the toss messages, and now the test automatically scroll to where we want. Now let me show you how this highlight works. As I told you, we can with the decorator we can change the behavior of its component by adding new functionality before and or after the component. In this case we are doing it after we find the component, right? After we find it, we're highlighting it. The way we highlighted it, we use JavaScript. So we use this script where we get with JavaScript the default background and the default outline of the actual element. When you use the execute script method in WebDriver, this will be replaced, this argument 0 will be replaced with the element that you provide here. In this case, this is the native WebDriver element. So we are getting the actual background, the outline, and then we can change the color to yellow and red. And then we use this special JavaScript function where that is going to be executed in automatically in 500 milliseconds. It's going to return the backgrounds to their original values. This means that we'll have this just for half a second. This will have this background. So this is our first decorator. The second is, as I said, is called scroll into view driver. It's up to you whether you call it scroll into view driver or scroll into view decorator. It's up to you. As you can see, we are again extending the driver decorator base class. We are providing it and we are calling the base constructor, providing the same. And then again, we are extending exactly the same two methods, the find component. Because of this nesting, this allows us to have more than one decorator that extends our original web core driver. This means that the first time when you find the component, it will highlight it. The next time it will pass the constructor and it will execute the scroll into view. Then it will pass to the next one that it's going, for example, to execute the logging. Then it's going to execute the find component. We have this recursion occurring, which is quite interesting and quite powerful. Again, in order to achieve the scroll into view, we have a simpler JavaScript here. Again, this will be updated with the wrapped element here, against which we are going to execute this JavaScript function scroll into view, and this will automatically scroll to our element. Now, if we look into the logging driver or the logging decorator, if you wish, again, we are extending the driver decorator. Then we are calling the base constructor. This is how we achieve this recursive algorithm here. You're going to see in a minute how we initialize them, and you'll get how this works. But again, the big difference here compared to the previous two versions is that now we are overriding most of the methods, and we are adding these console write line calls, basically that are going to produce the walk that I showed you here. You're going to see the same thing in the walk in the Lambda test, or in your Azure DevOps, or in your Jenkins or GitHub Actions, or whatever continuous integration system you use. So this sometimes is quite useful. So this is how we achieve it, but again, because we are deriving from the base class, this time we can override 80% of the methods. It doesn't matter. The rest 20% they are going to call the base class logic that is just calling and referring to the webcore driver original implementation. And what else? We also have the toast messages decorator driver. Again, in order to achieve these toast messages or these pop-ups that appear with some information that it's identical to what you saw in the console. But why this is useful? Because sometimes when you watch the videos in Lambda test or in your custom video recording, you're going to see directly in the video, which you're going to save time instead of, you know, going to a different system, walking into the walks, then connecting to the particular test. This is much easier because this is much easier to troubleshoot. Of course, you need to be careful with all of those JavaScripts. It can slow down your execution. But now we have every time, instead of using console write line, now I have this private method called inject notification toast. I got it from the framework that I developed, 𝐵𝒏𝒕𝒐𝒏. We are not using additional JavaScript libraries. If you watch some of my other videos about Selenium 4, maybe you remember that there we used other JavaScript libraries like 𝐾𝐞𝐬𝐢. It's fine, you can use that. But here this is plain JavaScript, just one call that is going to do the same. And it's already styled, but it's a lot of JavaScript, right? But basically it's going to create these pop-up messages. It's going to display the message there. We have a timeout, we have notification time, and anyhow, it's not important what we actually do here, but it's important how we are going to extend the driver. We can do the same for the eye component, and I did so because we have the component decorator. It works the same way. We're basically deriving, we are implementing all of the methods from this abstract class here. As you can see, we are overriding all of them, and this component decorator base class, it has the same purpose, to save us to you know, copy paste all of those implementations in all of the child classes. So we have this walk component. We are extending the same walk component decorator base class. We're calling the base constructor, and every time when we do a particular operation or calling a particular property, we are typing something to the console. This is how it works, and this is why here in the webcore driver, when you are returning the component base class, this is the place where we need to nest if we have multiple decorators for the component. And the other difference is especially in the tests. As I said, here we don't have changes to the page objects, which is great. Minimal impact to our tests. The only difference is where we initialize the actual driver. Because we have all of those base constructors that we need to provide the driver and then the driver to accomplish this recursive algorithm, we are nesting all the decorators. So we nest scroll into view driver or decorator, into the highlighting decorator, into the toast messages decorator, into the logging decorator, and then we are passing the original core logic into our web core driver. But again, the first find component, it will call the scroll into view. So we are going to scroll. Then it will call the highlighting find component, which will call the toast messages find component. Then it will call the logging driver find component, and then we're going to call the original find component that will return the actual component that we want. And this way, every time we are adding new logic and new logic and new logic. If we don't want any more to scroll into view, we are going to just delete this initialization, and this stops. If you want to add new behavior, that's fine. We're creating just one new decorator, we're adding it here to the chain, that's it. Excellent, right? Again, you can download the full source code from the links below. So yeah, we saw the problem, we saw how we can extend these adapters and add new logic to them. We created these 4 new decorators like highlighting, scroll interview, toast messages, logging. This is really powerful. It's excellent for even more complex frameworks, and I did that in many implementations of the frameworks that I developed. Even if you are creating a mini framework or a mini test library, this pattern is invaluable to create this extension possibility. In the next video, we are going to discuss the Singleton design pattern, which will help us to integrate many other patterns and ease the usability of everything. So stay tuned. If you have any questions, put them in the comments below. Thank you for watching. Also, don't forget to check the Lambda test blog and subscribe to the YouTube channel. And don't forget to get your free certification about JUnit, Selenium and others on the Lambda test certification program. Thank you and see you in the next video. Hi guys, greetings from Bulgaria. I am Anton, and in this video we are going to discuss the Singleton design pattern. In this course we are focusing on many design patterns that can help us in automated testing. We already covered the adapter and the proxy design patterns that help us to build a mini test library, extending further the 𝐊𝒏 interface, adding new methods and making our tests more maintainable. Then in the second video from the course we checked how we can extend further our mini test library using the Decorator design pattern. We added possibility, for example, to create decorators or plugins for highlighting, scrolling into view, building toast messages and logging. And in this third video we are going to focus more on the API usability, and we are going to learn about the Singleton design pattern, or how in another ways how we can access our page objects, factories, builders and other services. In the next video we are going to discuss the dependency injection pattern that can help us further enhance our mini test library, achieving a loosely coupled architecture and building and enhancing the test maintenance. Of course, later we are going to talk about chain of responsibility for building a troubleshooting feature for our framework. We're going to cover strategy design pattern for waiting and finding strategy to our framework. We are going to discuss different test data management techniques and learn about factories, repositories and builders. And last but not least, we're going to cover the data-driven testing, so that we don't need to always copy-paste the body of the test, but instead reuse one test for many test data parameters. So, if you haven't subscribed to the channel, please do so. Hit the ring bell so that you get notified about the many new videos that are published each week. Also check the Lambda test blog. There are many detailed articles about many best practices in test automation. And of course, check the links below. You'll find many resources. I'm going to remind you about some of them during this module, and you can get and download and clone the GitHub repo. You will find it in the description below. So let's get started. First, let's just a quick reminder for what is a design pattern. Then we're going to define the problem and we will directly start refactoring our solution. I'm going to quickly remind you our previous version that was based on the adapter. If you missed this video, check it out. And so, what is a design pattern? It is we can define a design patterns as prescribed solutions to everyday software challenges. They don't consist of code or any specified algorithm, but instead they describe how to group your logic smartly, reuse it, or to make it easier to maintain. To put it simply in one sentence, it is a template for solving design problems which we can use while we create our software solutions. So, what is the problem? Just quickly, I won't spend time creating these tests. In more details, I did this in the previous modules. I will quickly just show you the version that uses page object models and the adapter design pattern. I will quickly show you and explain all of the parts. But here are the two scenarios that we already implemented. They're middle complexity, since if the test is just too basic, then probably you don't need to use design patterns, but you can directly use Selenium, alright? So the first scenario that I built tests for is when you search a product here, and when you click on the product, by the way, here we select the product from the autocomplete using the product ID. You can check the previous video about how we write this dynamic locator. And also there is a tricky part here, since this expansion is, you need dynamically to wait for it. We already handled this with the adapters. So we compare this product, then we can return to the main page. We can search again for yet another product. We can open it, we can add it to the compare, then we can click here this compare or these two arrows, and we will navigate to this particular page. We abstracted the logic in our page object models. If you're not familiar with the pattern, please check the links below. There are a few articles about it and also a few videos on the YouTube channel about the page object model. But in short, the page object models are classes that they contain all of the web pages, web elements on a particular web page. So in a single place, you have how we locate the web elements. We have all of the actions that we can do. For example, filling the login form, the registration, or the purchasing form. And in some variations, like mine, I like to put the assertions inside the page objects, since in more complex scenarios there are additional mini logic inside the assertions, how we get the information to verify it, and also we can wrap there some exception messages to be thrown when the assertion fails. In this particular scenario, we abstracted some logic and made our methods more abstract so that they can support more than two products to be compared. And if we need to verify this information here, we provide the data, as we'll discuss in a minute, through model classes. These are simple classes where they have properties instead of having multiple parameters like 7 or 8, because this is not the best practice. The best practice is to have up to, for example, 5. More than that is making our tests more harder to maintain, harder to read, etc. So everywhere we're using these simple model classes that they basically group our parameters. So in order to verify the information here and to find it, we have special methods based on these labels. We use XPath locators, XPath access. Check in the links below, you will find an article more detailed how to write such locators. But basically through this label, in this HTML table, we are finding this particular row, and then we have a second parameter that it's basically the column index. This is column index 1, column index 2, 3, 5, no matter how many products you have. This is our first scenario. The second scenario is how we purchase a product. So we can pick this a product here. We can increase the quantity and add it to cart. Then we are going to click view cart. We can increase it from here or not. And most, again, here we can write many automated tests to verify multiple things. However, we're focusing just on a single workflow, where we'll just check here the total price. Then we are going to click checkout. Again, on the next page, we're just verifying the total, nothing more. There are hundreds of test cases here. There are other videos on the YouTube channel that we're discussing them. But here we are automating the basic flow where we are filling this required information. We are checking the, we are agreeing on the terms and conditions, and we are clicking continue. Again, there is a tricky part here with the JavaScript. Check the previous videos in more details to see how we handle this, but basically we need to scroll. That's everything. Now, let's return to the code. Actually, just let me remind you the diagram about the adapter. The adapter, we use it to extend the iWebDriver, and we have this interface iDriver where we have additional methods like wait for Ajax. We have a method start, that it's a factory method for initializing the driver. Also, instead of find element, we have find component, and inside this find component, in the actual implementation, which is called driver adapter, this implements the iDriver interface. We are creating the component adapter, which is a similar implementation but for the iWeb element. And this component, the way it extends the iWeb element is that now our components know how they were located with the this by property. Also, we have new methods or modified ones. Instead of send keys, we have type text. We have new methods like hover, etc. And in the actual implementation, again, we basically, through composition, we hold a reference to the actual iWeb element. This is, in short, our current implementation. So let's review it. As I said, I'm not going to type anything. I'm just going to explain through the code really quick, and then we are going to refactor it through Singleton. So in our current implementation, we have this all of these page objects. We have a base class called 𝑨𝒏𝒕𝒐𝒏. It's an abstract class. It means that you cannot create instances of it. We just use it as a base for our page objects. We hold references here to the iWebDriver, WebDriver wait, actions, etc. Actually, I'm going to review this version here with the iDriver. Here we have, instead of iWebDriver, we have the iDriver interface, which is the new modified interface. As I said, we have the start, we have the find component, etc. Check the previous video about the adapter. It's quite interesting and quite useful. So this is the actual implementation. The only thing that I did is that we are implementing the iDriver interface. As we discussed during the module about the decorator, you can achieve this through interface or through an abstract class. It doesn't matter, it's the same thing. So we have we use 𝐾𝐽𝐬, the composition principle, which is quite popular principle in object-oriented programming, where basically instead of inheritance, we contain instances of other classes that implement the desired functionality, like here, like private instances here. We can name them through the constructor, or basically here in the factory method I'm creating them right here. But this is especially important in languages like C# and in Java, where we don't have multiple inheritance. And like Lego, we can have multiple instances. This is quite better approach. So in our driver, as I said, we have the start, we have the find component where we are waiting for the element to appear. We are creating the component adapter, we return it. That's the adapter. So if we return to the page, as I said, we have just a base web page. In all of our pages, we just provide the driver to the constructor, to the base page. From then, after that, we have like properties, public properties of the elements, how we locate them. This is really great pattern where if there is a change in the locator, we're going to change it just in a single place. And after that, we have all of these methods that group all of the logic. They hide all of the nitty-gritty details, for example, whether we need to wait for Ajax, whether we need to scroll, etc. This is hidden inside the page object. As I said, we can have assertions as well. They're in my books I describe 10 variations of the pattern. In some variations we put here the assertions, in others we don't. It really depends what you want to achieve. So for example, the checkout page, as you can see, we have many such elements. We have methods like filling the user data. As I said, instead of having for example 5, 6, 7 parameters, we use these so-called POC objects or model classes, where we have these properties that have getters and setters for providing the data, and this is making our tests easier to use and our API. So we have these methods here. This is creating the so-called DSL or domain specific language, and when we check how we use the test now, like here, by the way, this is a regular NUnit project. If you're not familiar with NUnit, please check that there is a whole course about NUnit. There is an NUnit certification on the Lambda test website. There are tutorials on the blog. Really quick, when you click NuGet packages, we have installed these 4 NuGet packages needed for NUnit. Also, the most important dependency, of course, is Selenium WebDriver, and I have a few other related Selenium NuGet packages that are for backward compatibility, especially the WebDriver Manager. If you are using Selenium WebDriver 4.11 and above, you don't need the WebDriver Manager, because basically in the newer versions they use the new Selenium Manager functionality that downloads the drivers automatically for you. And if we return to the tests, this is a regular NUnit test class marked with this test fixture attribute, saying this is a class that contains NUnit. Then we have the setup. Basically, this is a test init method called before each test. Here is the place where we start the driver or the session. This is executed before each test. This is executed after each test. We are closing the browser or the session. So this is the place, if you use the Lambda Test Cloud, this is the place where you put your capabilities from the capabilities generator. So it doesn't matter. Here I'm using walk-off driver so that you can test it. After that, as you can see, if we use the page objects, by the way, I missed this, but I have this class, sometimes this is called app design pattern in my books, or a common class that basically holds references to all page objects. I prefer to use it instead of having base. We can still have base class for all of the tests, but basically this class is responsible for holding reference to all of our page objects. So this is the place in its constructor where I'm initializing all of the pages in a single place. This has the benefits where if I make a huge refactoring of what we accept here in the constructors, I'm going to change it in a single place, rather than, for example, if I have 20, 30 test classes, then I will need to go to many places to update the constructors. This is the benefit. And the second benefit, as we'll discuss later, is that when you use the dot, you have access to all of the pages and you know what they are. Since when we discuss the Singleton, our tests are shorter, maybe easier in some cases to use it, but you don't know what are all of the pages. But it will be up to you. It's a matter of choice and preference. So we are initializing here the model classes or our test data, and then as you can see, our tests now are quite readable with the page objects in this pattern. We built this DSL or domain specific language. They're reading the test cases. We're reading them as sentences. They're quite readable. So this is what we have until now. Now let's discuss the Singleton design pattern. The Singleton design pattern is basically quite simple. Maybe this is the simplest design pattern of all that we are going to discuss, but basically This gives you only one instance and it provides access to it. That's it. We can achieve this in different ways. The basic implementation is quite simple, as you're going to see in a minute. However, especially when we want to execute our tests in parallel, this makes our job more challenging. Because if you use a single instance, then there will be maybe problems, there will be deadlocks, because you're going to access a single instance of the driver or the page. So we need to solve this, and we're going to discuss at least 4 ways how we do that, and we're going to compare them, and then we're going to refactor the code that we have before. But now let's just give you an example. I have a version here with this is the no singleton version, right? This is how we use it until now. Then we have a version where we use the singletons. So this is a single version. This is usually how it works. In the singleton, in Java, for example, you're going to have, like in the diagram, a method called getInstance because we don't have properties. In C#, you're going to have a property called instance. And this instance is responsible for the first time when you call it, it will create an instance of the object, and the next time when, for example, like here, the next time when you call it, it will return the same instance of the page. And in our case here, I made this thread save. It will return the proper instance for the particular process. So we're going to save an instances. We're going to return them based on the particular thread or a process where we create them. I created here a copy of our adapter so that I can show you a simple refactoring of how we can create the basic versions of the pattern. So in the most straightforward way how we can implement it is that we need a static private variable to the same class. In our case, this is the card page. I'm going to call this instance, and then here I will have a static property that it's going to return the same class. In our case, this is the card page, and as you saw, this will be called instance. Now we need only the getter, we don't need the setter. So here we need to have a check whether the instance is null or not. So here I will create an if where we check whether the instance is null. If it's null, then we are going to initialize it, and we are going to return here the card. Now I'm going to do the refactoring later because since we need to pass the driver, I need to refactor the driver adapter as well. In a minute I'm going to show how we can do that. For now I'll just pass new, but imagine that we are passing here as a singleton the driver adapter. And next we can return here the instance. Or you can do it like this. For example, in C# we can use this syntax instead of having this, and then we can make it even shorter like this, or even shorter if we have just get, we can make it like this in a single place. This is the singleton. Excellent. Now as I said, this is not thread safe, and also the problem here is that every time for every page we need to create that. As you can understand, this is a lot of copy-paste code. We don't want that. So we can move all of this logic into our web page and make this base page maybe generic, so that we can reuse the singleton. So let's create that, and I'm going to rename it to basic singleton. So in this version, base singleton, we don't need this constructor anymore. In a second, again, let's accept that probably we are going to use this driver as a singleton as well. Anyhow, we need to pass the type of the page, so we are going to provide here a parameter called tPage, and we need to have this constraint where we need to mention that tPage is actually a class, and probably that it contains a constructor. And now we can have a private static tPage instance, and below that we can have the property that will return tPage. It will be again static. This will be called instance, and let's write the regular version with the get so that it's not too short, because I know that this is hard for some people. That's completely fine. And we can check whether the instance here is null. Here we are going to create new tPage, and then we are going to turn the instance. This is how we created the web page basic singleton. And now if we return to our car page, now I can change it like this and use car page here. Again, we need an empty constructor now, and here we need to remove this one here. Again, we are going to initialize this driver. Imagine that we are going to get it through a singleton in a minute as well. So yeah, that's it. And everywhere we just need to do this refactoring for the checkout, for the home page, etc. Again, this is in the most straightforward way where we don't execute our tests in parallel. If you don't plan to execute them in parallel, that's completely fine. Don't go and implement the other things that we are going to discuss now, because this will make your test much more, harder to maintain and more complex than needed. There is this principle in software programming where if the simple, more straightforward solution is working for you and the code is equally maintainable, then don't go and write something more complex. Now, let's review the other solutions that are thread safe, meaning that you can use them in a way that basically solves this problem. The first version is if you use this thread static. Again, if you watch here, this particular base class, it accepts a generic parameter t. Again, we mentioned that it needs to have an empty constructor. It's similar to what we created before with the basic version, but now we marked our static variable with this thread static attribute. This indicates that the value of the static field is unique for each thread. This provides a separate copy of the field for each thread or for each process. However, it requires careful management to avoid memory leaks, and the initialization is not straightforward as in other methods. Now, we have another version that if you clone the repo, you're going to see it. It's much more complex. It uses this internal static class singleton factory where through reflection we are creating the instances. This is another way. I'm not going to discuss it now because it's not my preferred way. Instead, we are going to check another version that it's using the native lock mechanism in C#. This lock mechanism, how it works? Again, we have the generic parameter, we have the generic constraint, we have the private static variable, but we have a new static variable that it's read-only of a type object. And we are creating one instance of this lock object. And the big difference here is that we wrapped our basic Singleton version inside this lock. And this is using this locking mechanism that ensures that only one thread can access a certain block of code at a time. This is achieved through this lock. So, what are the pros? This is simple and straightforward to implement. It guarantees a single instance in a multi-thread environment, works well for lazy initialization. It can lead, however, to performance issues due to thread contention, especially if instance is accessed too frequently, and it has an overhead of locking even after the instance is initialized. Again, maybe in our case in automated tests we are not going to access it so much more, so maybe it's fine to use it. However, I have two other preferred ways. One of them is using thread local. This solution, for example, if you use Java, it's the solution for you. In Java we have thread local as well, we don't have lock. So this thread local solution is it provides a thread specific data storage. Each thread has its own instance of the variable. This particular container, we initialize it through these lambda expressions, where we create again the object. And in order to access the actual storage, thread safe storage, you need to access it through this value property of this instance, this static instance. It works the same way in Java. So it ensures this thread safety without locks. It provides each thread with its own instance, which is useful. Behind the scenes, how it works, it ensures, again, each thread has its own instance. On the first access by the thread, the variable is initialized, typically via provided lambda expression. Sequential accesses fetch the thread specific value directly, avoiding contention and ensuring thread isolation. Setting a value stores it only for the current thread. It is crucial, however, to dispose it of the thread local property to prevent memory leaks in long-running applications. Probably in our cases we're going to run our tests for many minutes or hours. The performance benefits comes from eliminating this locking overhead through memory usage. However, the memory usage might increase with the number of threads due to each holding a separate instance. However, probably in our test we won't have so many threads. Now, this is why I implemented here this 𝐴𝐸_disposable interface, and I implemented this dispose method. You will notice here that I use this encode specifically the garbage collector. This using of garbage collector suppress finalize is particularly important for classes that manage unmanaged resources like threads directly or indirectly. It ensures that the resources are released as soon as possible without waiting for the finalizers to be called, which might happen much later or undetermined at particular time, potentially leading to resource leaks. In my case, where we use this website class, here I implemented the 𝐴𝐸_disposable interface as well, and this leads to basically this forces you to implement the dispose method as well. And if your pages are using the thread local base class, then here you need to call everywhere their dispose methods. In NUnit, we need somewhere to call this dispose method of the website. So in NUnit, the proper place to call this is this global test tier down. In MS Test, we have a special attribute called assembly cleanup. So the proper place to put these dispose methods is in this assembly cleanup method. Basically, this assembly cleanup method or run after all tests, as you can guess from the name, this will be run after all of the tests, and this will dispose all of the pages. So in any unit, we do that with this one-time tear down attribute. The important thing here, if you read later all of the descriptions here, is that you need to put this inside the global namespace, not in a specific namespace. So the last version that we are going to check, in my preferred way in C#, is using this lazy class. So you will notice again, we have the generic, we have the constraint, then we use this lazy. So the lazy is a feature in C# that allows you for delayed creation of an object, meaning that the object is only instantiated when it's first needed. And it's thread safe by default. Lazy initialization is not created until it's needed. It has this performance benefit that no lock overhead after the instance is created. It has internally slightly more complex implementation, but you don't need to care about that. You just need to use it. Again, just lazy t equal to new lazy, provide here how we are going to initialize the proper object. Like with the thread local, you need to access it through this value attribute. So in my refactoring, the thing that I did is, as I said, we need to refactor the driver adapter to be Singleton as well. So I have not thread safe version. If you need that, you can use this version. As I said, if you're not going to run your tests in parallel, use this version. Otherwise, I implemented this lazy driver adapter. As you can see here, we are creating the new driver adapter. If you use decorators to further extend your mini framework, then you need to initialize the decorators right here. After that, in our pages, in our web page, I'm deriving from the thread safe lazy base singleton, where we provide the T page, similar to how we implemented the first time. And as you can see, now our constructor is not accepting the iDriver interface, but instead we have an empty constructor, not an empty, but without parameters, and we are accessing directly the driver adapter from the instance property. Again, this is thread safe, meaning that you can run your tests in parallel on the Lambda Test Cloud, and this will work as expected. After that, you just derive as usual from the web page that we refactored, just mentioning the actual, we are exchanging the T parameter from the T page with the actual class type. That's all. Again, if we don't use singletons, we access it directly from the web page, or maybe you can skip the website class and you can use the web pages directly from the instance property. Some people prefer that. Also, this is not only for related to page objects. Later we can use it for factories, for repositories, for builders, for whatever classes you like. This is actually a version where we use website singleton and we access singleton versions of the web pages. So you have multiple versions to pick from. This is what we covered. So what we covered here, we reviewed a solution with page objects without singletons. We use the adapter, then we refactored, and the singletons help you to have a single instance of a class, but without without making all of your methods static, because if you do that, you cannot use base classes and reuse all of the logic. However, the singleton gives us both of the benefits. We can still derive from base classes and still have a single instance. And we reviewed a few solutions with thread local, with the lock object, with lazy, with this thread static attribute, how we can achieve thread safe versions of these base classes of ours that give you the singleton design pattern. And again, if you're not going to run your test in parallel, just use the base version of it. In the next video, we are going to cover the inversion of control principles, so stay tuned. Please put any comments below, and also I will gladly hear what patterns you want to learn more if they're not in our series. So thank you for watching. Check the Lambda test blog for more helpful articles, and of course check and get your free certifications about JUnit, Selenium and other technologies. Thank you and see you in the other videos. Hi guys, greetings from Bulgaria. In this module we are going to cover the dependency injection pattern. Until now we have covered in this course about design patterns in automated testing. We first covered the proxy and the adapter design pattern, improving the interfaces of iWebDriver and iWebElement, making our test much more stable and much more maintainable. Then we covered the Decorator design pattern that help us to extend further our mini library and allowing us to write some particular extensions without breaking the solid principles. In the third video we discussed the Singleton design pattern for, in certain cases, it helps us to improve the API usability, or basically how we call different page object models and other services and factories. And now in the fourth module of this course we are going to cover dependency injection. We are going to discuss two things. First, how to use dependency injection frameworks such as Unity in C#, and also we are going to cover the service locator design pattern. But first, if you haven't subscribed to the channel, please do so. Hit the ring bell so that you get notified when new videos are published. Many new videos are published each week. Also check the Lambda test blog, because there are many detailed articles that discuss the modern test automation problems and their solutions. In the show notes below, in the description, you will find the GitHub repo with the full source code. I suggest to clone it and play along with the video. And if for some reason I'm moving too fast to particular sections of the code, just hit pause and or return. If the pace is too fast or too slow, you can always decrease that and improve the different resolutions of the video. You will find additional resources in the description below. So let's get started. First, we are going to cover what was the original problem. If you haven't watched the previous videos, I'm going to just quickly summarize the solution that we are going to improve later. With the inversion of control containers, we're going to cover many of the different related terms about the dependency injection pattern, and of course most of the time we're going to see some demos. I'm going to use an old archived project of mine with a complex tool that it's using heavily dependency injection frameworks, and we are going to refactor the existing project with a few tests that it's using the adapter pattern to use the inversion of control, and we want to achieve two things. As you know, in particular projects, sometimes it's necessary to rewrite the website using a new technology, for example, converting it to be a single page application using new technologies like Angular or React. And in such cases, we don't want to completely throw away all of our tests or copy-paste them and initiate this heavy refactoring. Instead, we can utilize architecture where we support two different versions of our, for example, page object models, where we define different locators and maybe if there are slight changes in the logic. But the core of our test will stay the same. So we are going to see such solution. And then we are going to discuss related design pattern to the dependency injection frameworks. It's called service locator. In many instances, it's not suggested to use it, but in our case for in test automation frameworks, sometimes when it's used with care, it can benefit us. And we're going to see how we can achieve similar plugin architecture to the one that we achieved with the Decorator pattern, but in some instances it might be even simpler. So it's just another way you can pick some of them. So let's get started. First, let's cover the dependency injection pattern. Here are some terms that we need to clear first. The first one is a broader principle, the inversion of control, or in short IOC. This is a broader principle in software engineering whereby the control flow of a program is inverted compared to traditional procedural programming. In this paradigm, rather than the application directly invoking the methods of a framework or a library, the framework invokes the methods provided by the application, as you will see in a minute in the demo application that I'm going to show you. And this allows more flexible program behavior. Then we have dependency injection, or DI in short. This is a specific form of IOC, or inversion of control, where dependencies, services, objects are provided to the related component, such as a class or a function, externally, typically via the constructor, but sometimes this can be done via properties. This allows the component to perform its functions without being responsible for instantiating its dependencies and thus adhering to the principles of separation of concerns. And dependency injection frameworks, they are specialized tools for that facilitates this dependency injection. They often allow developers to define interfaces or annotations, particularly in Java, that streamline the process of this injecting implementations into the components that require them. Before we fully define the dependency inversion principle, let's now discuss directly the code. This is the project that I mentioned. It's called 𝐾𝐻𝐬𝐬. This was a long time ago. This was a project that here we at Automate the Planet we maintained. It's a distributed runner that allows us to run tests on multiple machines in parallel and then merge of the results. For a few years it's already archived, we don't use it, but back in the days when there weren't so many solutions like HyperExecute, for example, the smart orchestration, we had to build our own thing. And the idea here is that it was built to be programming language agnostic, meaning that we could run distributed tests, for example, built on .NET or Java or other languages. So here, in order to build this testable architecture, I used the so-called onion architecture. It's out of the scope of this video. If you're curious, you can Google. However, the main thing here is that we have the main business logic in these core services, that it's responsible for, time distributing the tests, filtering them, achieving the history and everything. But all of the dependent, infrastructure, like working with files, directories, console, etc., they're in a separate project called infrastructure. However, we are not directly referencing the infrastructure inside our business logic. Instead, the whole idea is that we are using a lot of contracts or interfaces. And the thing that it's connecting both of them is actually this dependency injection framework. In this particular instance, and in other demos, we're going to use Unity. This is a very popular open source inversion of control container framework in .NET. You can check it out. And if we look into one of our core services or the main business logic, you'll see that here we have, through composition, a lot of interfaces instead of directly referencing other related services. And as I said, many often through the help of this inversion of control containers, we are injecting them through the constructor. And we are doing that in for all of these services. And then another place that it's very important is here the main program, where we register the different interfaces to the container. Now it's time to give a definition of this inversion of control containers. Now, when you saw some examples, these IOC containers, such as Unity, these frameworks help implementing this automatic dependency injection in the constructor, because it's not just a single class. This class can depend on other dependencies, the other dependencies can depend on other dependencies, etc. It can be a long tree of dependencies. And this IOC container manages the instantiation and provides the required dependencies that classes without the classes needing to create the instances themselves using the new keyword. With an IOC container, you typically register the types as shown here, and their dependencies up front. Here we mention, for this interface, please initialize this particular class. These dependencies can be, so a few advantages. First, objects do not need to know how to create their dependencies, which is great. This reduces the coupling between the classes and makes the code more maintainable. Then, from configuration standpoint, dependencies can be managed externally from the components that use them, often through configuration files or code-based configurations like this. It makes unit testing easier. In a minute I'm going to show you such examples, because dependencies can be replaced with mocks and stubs, and the IOC container can manage the life cycle of objects, allowing for singletons on or transient instances, among other lifecycle management options. They are provided here as a separate parameter to the register type method. And then when we want to then we have this resolve. When using the IOC container, we don't need to create the objects manually. The container does it for us. This is called resolution. The container must include some methods to resolve the specified type, and the container creates an object of the specified type, injects the required dependencies if there are any, and returns the object. And also the container is responsible for managing the lifecycle of the dependent objects, and most IOC containers include, as I mentioned, different lifecycle managers. Also, you can, if you want to achieve, for example, and use the containers in multiple threads and run your tests in parallel, we can do that. If you watch the video about Singleton, we took care of this there. We can use log statements and also use child containers, but here I will keep it more simple. And I promised to show you some unit tests. Here I have unit test projects. I used a library called mock to manage these mock objects for those interfaces. But the whole point is that we isolate all of the dependencies. For example, for this particular class, we are going to create mocks for all of those dependencies and interfaces. The mock library will create fake objects or real implementation for them on the fly, using most of the time reflection, but this is hidden from you. And then using the mock framework, using mocks and stubs, we can configure the mock when the actual class and when we call some of its methods. When this class internally calls the dependency and its fake implementation, what needs to happen? In this case, I'm saying, please, when I call get all, return these fake results. Or another thing that we can do with these mock frameworks is that we can verify that particular method internally was called a few times with particular parameters. Again, this is not a video about mocking and going into these details about unit testing, but the whole point was that many often this inversion of control containers are used to achieve this 𝐾𝐬𝐬𝐷 architecture, to make it more testable and later to allow us to write such unit tests. Of course, in automated testing, we don't care about that because we are not going to write unit tests for our UI tests or system tests, right, or API tests. However, we can use the IOC containers slightly in a different way to help us facilitate other things. Now, if I need to finalize the terms and finalize like the definition for dependency inversion principle, here it is. Dependency inversion principle, or in short DIP, is a guideline in object-oriented design which states that high-level modules, such as, for example, this test agent run provider, this is the high-level module, should not depend on low-level modules like all of those. Both should depend on abstractions like these interfaces here. Furthermore, these abstractions should not depend on details like models and others. Rather, details should depend on other abstractions. I know that this is a little bit too abstract. Now we will go and refactor our previous solution with the adapter and see how we can achieve these two options for our page objects that will allow us to reuse our tests in case our website is rewritten. Again, this happened to me a few times in projects that we are involved, and this can be quite useful. Now, let me quickly remind you, because if you haven't watched the previous videos, I suggest to check the first one, because there I'm writing with a lot of details and explanations the test that we are going to refactor now. I tried to create a little bit more complex tests because many often, like we discussed in the previous modules, if your code is too simple, probably you don't need to make it further more complex with design patterns. But if we want to make our tests more readable, more maintainable, and don't use, the copy pasting a lot, then we need to use these design patterns, and this is why we are creating this course. So the first test there was that we are adding a product. We are searching for a product. We are opening it. Then we are click on compare this product. Then we return. We add another product. The problem, by the way, here that we solved with the adapter that I'm going to show in a minute was that many often we had to use thread slips because this additional functionality here, depending on the server load, can take from a couple of milliseconds to maybe a second or two, and sometimes if you don't manage properly the waiting strategy, the test might fail. So basically we use the adapter to hide in a central place when we search for components to wait internally for the elements. This was one of the things that we solved. And also we extended the iWebDriver interface, as you will see, providing additional methods like, for example, wait for AJAX requests. So we are clicking compare this again, and we can add the second product but a different one, for example this refrigerator. And when we go to the compare screen, we use model classes to verify basically whether the information here is correct or not. And through the page objects, if I need to summarize real quick what is a page object model, as you will see, is just a single class where we hold the map, or how we find all of the elements. If we need to fix it, we fix it in a single place. Also, we group all of the different actions, and in some variations like mine, we can put assertions. That's it. But with these actions, I made it more reusable. If I have other test cases where I need to verify more than 2 products, 3, 5, depending on the test case, we can do that using these generalized methods. And the second test was when we add to the cart and we increase the quantity. We click view cart, we verify the total. Again, here we are just covering the 𝐵𝒐𝒕𝒐𝒏. Here you can write many tests different. However, we are just filling the required information, checking the total, and that's it. And click continue and finish the order. That's our test. And now, here's the project. You can download the full source code from the links below. This is a regular NUnit project. If you're not familiar with patch object models, NUnit, check the links below. There are separate videos and whole courses about that. This is a typical NUnit project where I used and installed all required dependencies. Like I have all of the dependencies for Selenium, of course. The most important one is Selenium WebDriver. Also for backward compatibility, I added Selenium support, WebDriver Manager, and wait helpers. If you're using a version 4.11 and above, you don't need to use WebDriver Manager since it includes the Selenium Manager by default, which is downloading the driver and even provides browser management, which means that even if you don't have a Firefox, it will download a portable version. And then for the NUnit, we need these 4 NuGet packages. That's it. Then in the adapter, we have these page object models. We have a base page that contains our improved interface, the iDriver, which is part of the adapter pattern. If you haven't checked this video, check it out. But in short, this improves and allows us to add new methods to the iWebDriver interface, to this interface that it's wrapping, and also allow us to modify a little bit how the methods are working. So we added a new method start, we added a new method wait for Ajax, we renamed some of the methods. For example, instead of find element, now we have find component, and the actual implementation of the driver, it's implementing this iDriver interface. We have this factory method for this adapter allows us to control better the initialization of the driver, allowing us to control when we want to initialize it and how. Here for backward compatibility I use WebDriver Manager, but the important thing here that I implemented was that we're waiting internally in the find component every time for the element to exist before we return it, and then we wrap it in this component adapter, which is the improved version of the iWeb element, where through composition we are holding instances to the iWebDriver, to the iWeb element. We improve the interface by holding a reference to the bilocator. We wait, for example, before clicking an element for the element to be clickable, and so on and so forth. And in the page object models, as I said, we have the base class for all pages. Here, through the constructor, we are providing the interface to the iDriver. We have reference to the different elements and how we locate them. This gives you the possibility to, if something is wrong, you can fix the locator in a single place. We also extracted different actions here, building this DSL or domain-specific language. And as I said, we improve it so that we don't need to use these thread slips. And also we have this wait for Ajax, waiting for this asynchronous behavior automatically. That's basically the adapter. Now let's see how we can use the Unity container in action. I have this version 3. Before we talk about the service locator, I'm going to compare them with the vanilla dependency in version frameworks. So here now, in order to create 2 versions of our pages, you can do the following. As you can see, I created these additional contracts for all of the pages. It depends how big the change is. If it's just how you locate the elements, then probably you don't need to put all of the logic in the in this interface, but instead you can just move the element map or the actual components, how you locate them. However, for simplicity, I moved all of the actions and all of the assertions and all the public properties, or basically my elements. I did that for all of the pages. As you can see here, this is the checkout page. And how I did that fast, you can open the page and you can click Alt Enter, and Visual Studio is suggesting for you to extract the interface. You can press Enter, and now you can, as you can see, define the new type. You can specify the name of the interface, the name of this new file, or add to the current file, but this suggests the process usually to move it to a separate file. And then you can pick which properties and methods you want to move to the interface. This is how I extracted this interface really quick, and Visual Studio is doing the refactoring automatically for you. Now, how this help us? Well, in this actually, if we return to the adapter, I missed one class. This was the website class, which was the central point for our page objects. As you can see here, instead of defining them in every particular test, I have this single class responsible for initializing them once and giving us access to them. The benefit here is that when you type here the the tests, you can type website dot, and you can see all of the different pages through the autocomplete. Here you can type page and you can pick from the list. Otherwise, you need to explicitly every time define the pages on top or in a base class. So I prefer this approach. And also, if there is a refactoring like right now, instead of like here in this website, if we go, you'll see that I provide explicitly I'm creating the pages with the keyword new. But as we discussed previously, the container is responsible now for creating the instances of the dependent objects. So I refactored our website in this version 3 to use this Unity container. In order to use the Unity container, I installed this Unity NuGet package. This is the only thing that you need. Then I of course added this using. You can add it as a global using here. That's it. Then I have a private variable to the container, and as you'll see in my tests, I created the Unity container there since I registered there the driver. And here in the constructor of the website, I am doing this resolution, or I'm creating, basically I'm getting the current instance of the driver because I registered it before, as you'll see in a minute, as a singleton. I have just a single instance of it. And then I registered my interfaces to their actual implementation. This is version 1 of my pages. For version 2 of my pages, I can change completely how they work. What I mean here is that imagine that this is my jQuery version of the website, that it's not a single page application. It has this particular locators. However, in the refactored React version, the thing that you need to do is that you need to copy. We need here to create a separate folder, version 2. I copy paste them. Then I, of course, here second version. I need to change everywhere the namespace. But as I said here, we change all of the locators like in the React. So here, if I copy this, and of course you need all of the interfaces and the web page. But the whole point is that we are going to change the locators. We are going to change the logic here. And by doing that, since we have a second version of those objects, we can register them instead. Here I can register the second version. Now, instead of using the fifth, I can, copy this second version. This is the only change that I need to do later. Of course, I need to fix here the namespace of the interface. But this will change how and which version of the page my tests are using. You can have multiple versions. And if I return, as you can see here, we are registering the types. If you have a different version registered, then when we resolve them, when we get the public properties, this will return the version that we registered above. And again, the container is responsible. As you can see, previously we used the new keyword. Now the resolution is doing that for us. Also, we won't probably have a separate module about facade design pattern, but I implemented a simple facade. I wrote in multiple occasions in the videos that probably you watched some of them on the channel. I used the facade. Basically, the facade allows us to define a big workflow. As you can see here, through construction injection, I provided the dependency pages, and here I use the pages for defining one core method for purchasing products. And of course, we have different parameters for achieving the workflow. And we can use the container to resolve all of the dependencies instead of defining them through the new keyword. Here is how we use them. This is the first version where we don't use the facade. Here we have a private instance to the container and to the website. We create the instance of the container, we create the instance of the adapter, we register the driver inside the container. This register instance is basically creating and registering the driver as a singleton. Then we provide the container as a dependency to the website. Since the website is responsible for registering the proper version of our page objects, this is the single place where we need to change if there is a version 2. And then the rest of the tests, they absolutely the same. Just with a single switch in a single class, we can switch from version 1 to version 2 of the test. However, we'll preserve the main workflow of the test, all of the data that we use here, and everything else. No copy pasting. If there is a change, it's only in the pages and in their version. We can support for a particular time 2 versions of the containers. That's not a problem. As I said, there are some articles about Unity that you can control that via configuration files, which can further improve our solution. And if we look into the solution with the facade, here actually we need to provide the container. We are doing the same. We are creating an instance of the container, we are creating an instance of the adapter, we start the browser, registering, and later the only thing that I wanted to show you is how we resolve the facade. You saw that the facade is dependent on our 4 objects. However, since we are using the Unity container, this dependency injection framework, it will create automatically for us all of the pages that was registered previously, and it's going to resolve properly the facade with the right instances. And now we can just directly call the facade. Lastly, I want to discuss another design pattern. It's called service locator. I implemented it here quickly. This is the service locator. We use lazy. If you watch the video about the singleton, there we discussed that this is a container in C#, a special class for lazy loading. It's thread safe by default. This is how we implemented the singleton pattern for the service locator. And the service locator pattern is a design pattern used to obtain the dependencies from a central registry. It acts as a registry that classes consult to obtain their dependencies explicitly. So how it works? In the service locator pattern, it provides a way to look up dependencies by a key or a type. In our case, this is the type. Like here, we need to provide the actual interface. So the client class, it asks the locator for the dependency instead of creating it. So what are the advantages? First, simplicity. It is often simpler to use for small projects or single-use applications. It provides a single point of resolution for dependencies, which can simplify configuration management for simple scenarios. Again, in some instances, this might be an anti-pattern, especially if you want to achieve testable architecture. And here the key differences compared to the IOC containers. So IOC containers use dependency injection to provide dependent objects, while the service locator is explicitly asked by the client to provide these dependencies. With IOC containers, the container has control over the lifecycle of the dependencies. In contrast, the service locator pattern leaves the control to the client, who must request the dependencies. IOC containers help to reduce the coupling by managing dependencies outside of the client code, while the service locator, on the other hand, requires the client to be aware of the locator, which can increase the coupling. This is why some people consider this in many occasions this to be an anti-pattern. And IOC containers typically offer easier testing as dependencies are injected, often through interfaces, making mocking more straightforward, while the service locator pattern can make testing harder because it may require the locator itself to be configured in the test environment. And the service locator pattern can lead to code pollution with locator calls, while IOC container keep the logic separate from the business logic. Again, since this is mini test framework, usually about the most disadvantages of this service locator, probably we don't care about them. This is why in some instances, when you are careful, this can be quite helpful. So I implemented this service locator to show you how we can extend the adapter, the place, how I extended. If you watch the module about Decorator, we added decorators for highlighting when we do particular actions for the inputs, or clicking a button, or providing toast messages and providing logging. And we did that inside these find component methods. Before the usage of the service locator, I had to modify directly every time my adapter, providing these private methods here, for example, for scrolling or for highlighting, and directly editing every time my methods. This is breaking some of the solid principles, especially the one that it's stating that our classes should be open for modification but close for modification. Should be open for extension but close for modification, which means that every time when I am doing such changes, this might trigger regression in the code that it's using my methods, my class. This is why these plugin architectures, like with the decorators or the usage of the service locator here, can help us build these plugins. So in my case, I use the service locator instance here, the Singleton, to resolve all of the plugins. I defined this iDriver plugin interface. As you can see, we have two methods, onComponentFound and onComponentsFound. And every plugin can override them, it needs to implement them and provide logic. So I created two plugins, one for highlighting. So here in the highlight element plugin, I implemented this iDriver plugin, and in the implementation of onComponentFound, basically I call the highlight method, which is using some JavaScript. We get the original background color and the outline of the element. We change it to yellow and red, and through setTimeout function we are returning it back after 500 milliseconds. And this way we can achieve this highlighting. Since we don't have an instance here for the driver itself, we can provide it as a parameter, but since I don't have it, I wanted to showcase how we use here in order to be able to execute the JavaScript. I use again the service locator singleton to resolve the driver and to get it from the service locator, and I execute the JavaScript. I did the same for the second plugin about the scroll into view. The thing that it's doing, basically the purpose of this plugin is that if you have longer pages, this JavaScript is going to scroll to your particular element, and you are going to view it on the video and also be able to perform particular actions. Here the code is much simpler. It's just this simple JavaScript. Again, we are using the service locator to get the instance to the driver, execute the script, and I'm doing this inside the implementation of these two methods. And the place where I actually execute the plugins is that here I resolve all of the instances, or all of the instances of the plugins that I registered in the service locator, and we for each them and execute their own components found, providing the current wrapped element. This is just for each them through Lambda expressions. I did the same here. Again, if you have another plugin for logging or for toss messages, as we did in the decorators, you can just register the additional plugin against the iDriver plugin, and this automatically will add your plugin. It will be executed directly here, which is excellent. This is like, you can achieve that through implementing Decorator, or if you check some of my articles, or if you have my books, you can achieve that through a much more complicated observer design pattern. There are other ways, but this is one of the implementations if you use the service locator other ways. So we walked into the in the next video we are going to cover the chain of responsibility design pattern. We are going to use it to achieve very comprehensive solution that we will add to our mini framework for troubleshooting errors if our tests are failing. So check it out, stay tuned. If you have any questions, put them in the comments below. I'll be really glad to answer. Also, if you want to hear about other design patterns that we are not going to cover, put your wishes in the comments below. And of course, don't forget to check the Lambda Test blog and to follow us on the community lambdatest.com, and to get your free JUnit or Selenium certification and others. Thank you for watching, and see you in the other videos. Hi guys, greetings from Bulgaria. In this module we are going to cover the chain of responsibility design pattern. In the previous modules out of this course about design patterns in automated testing, we covered the adapter and proxy design patterns. We use the adapter to improve further the iWebDriver interface and the iWeb element. We added new methods. We make our tests more maintainable. In the second video, we discussed how to extend this solution further with the Decorator design pattern, adding highlighting, toss messages, logging, and others without breaking the solid principles. We discussed after that the Singleton design pattern for improving, in some cases, the API usability of our page objects, factories, builders, and others. Quickly after that, we saw how to use the dependency injection pattern together with the service locator to create loosely coupled architectures, even introducing another way for extending our mini test libraries. And in this particular module, we are going to cover the chain of responsibility design pattern, where we are going to use it to create this advanced exception analysis and for troubleshooting of our tests. Next, we're going to cover in the next module the strategy design pattern. If you haven't subscribed to the channel, please do so, hit the ring bell so that you get notified of any new videos that are published each week. Also check the Lambda test blog for many detailed articles about the modern test automation problems and their solutions. In the description below you will find many related resources together with the source code. I suggest to download the source code from GitHub and work together with the video. You can pause for certain sections to check more detail about the explanations that I'm giving about the code. And if the pace is too fast or too slow for you, you can just decrease the pace of the video and also change the quality. And for those of you that want to hear just particular part of the video, there are jump links in the description as well. So let's get started. First, we're going to describe what is this exception analysis, why we should care. Then we are going to check the classic diagram of the chain of responsibility, and then I'm going to show you the modified version for our particular problem. And next, quick refresh for those of you who haven't watched the previous modules where in details I was explaining this test project that we are going to refactor. Just a quick refresh for you. What are the test cases and the different patterns like the adapter, because we are going to modify it further. If you watch them, you can skip this part. Again, jump links in the description. And then the next big chunk, the most important part, will be to explain how we use the chain of responsibility pattern to do this troubleshooting. So, the most time-consuming activity in automated testing, after the writing the automated test, of course, is the test failure analysis. It is possible in the long run this to be even more time-consuming than depending on the complexity of the tests, the test framework, and the code quality. And when the test failure is more accurate and understandable for people who didn't write the actual tests, I believe that the required time for maintenance will be decreased. This is the main reason why we are going to use this particular pattern. I decided that this chain of responsibility design pattern is a good fit for the job because we need an algorithm similar to exception handling in C#, Java, or JavaScript. We start the analysis from the most common reason causing failures, and if the check doesn't succeed, we continue with the more uncommon reasons. Such check can be, for example, yellow exception screen, file not found, page not found. Later we are going to check for JavaScript exceptions that occurred during the execution of the test, JavaScript warnings, or performance handlers, and many more, or failed requests. So I developed this idea even further with the introduction of these test case specific handlers that we're going to discuss, but without further ado, let's see the diagram for the actual pattern, right? So the chain of responsibility design pattern avoids coupling the sender of a request to its receiver by giving more than one object a chance to handle the request. This pattern chains the receiving object and passes the request along the chain until an object handles it. So we have the handler, as you can see below, and this handler defines the interface for handling the requests. Optionally, it implements a successor link. In our case, as you'll see in a minute, we will have a special method for assigning the next handler part of the chain. This can be an interface, this can be an abstract class. In our case, this will be an abstract class. Then we have the concrete handlers that handle the requests it is responsible for. It can access its successor, and if the concrete handler can handle the request, it does so, of course. Otherwise, it forwards the request to its successor. That's it. And the client, or in our case, this will be our driver adapter, it basically initiates the request to the concrete handler object, part of the chain. That's it. So this will be our code now, where we will have this base class exception analysis handler. It will contain an abstract string property of the detailed issue explanation. The whole reason for that is that we will call 𝑣𝒏𝒕𝒐𝒏 method, which will return boolean, whether this reason is true or false. If it's true, we are going to throw a special formatted exception with the detailed issue explanation. This will help us when we check later in our reporting tools whether we will see the actual reason with some details that we are going to provide in this issue explanation. In the driver adapter, as you can see from the right, we'll call this analyze method, where we will supply the driver and the actual exception that we are going to analyze. And as I said, optionally, but in our case, of course, we want that, we'll have this method add exception analyzation handler that will accept the next handler in the chain. Because if this particular handler is not applicable or it's not meeting its rules, then this handler will just call the next one. For example, this custom HTML exception handler will check for particular string in the HTML. If it's not applicable, it will call the file not found exception handler, that it will check for another thing. If this is not applicable, we'll check for performance metric that we can measure using the CDP and bidirectional APIs. If you're not familiar with that, in the links below you will find there is a dedicated course that I created about CDP and bidirectional APIs in Selenium 4. We can check for console warnings again using bidirectional APIs and so on and so forth. We can have unlimited number of handlers. So before we see the actual implementation, for those of you that haven't watched the previous modules, let me quickly refresh what we did before. For the rest, you can just skip to the part where we refactor the solution. So we are our mini test library have two tests that I decided to be a little bit more complex. Otherwise, if it's just too simple, probably it doesn't need to implement such design patterns. So we are searching here for a product. This is the first test. So we search for a product, we added it to the compare screen. Then we move again to the home page. We search for another product. We added it again to the compare screen. Then we click compare. We do that, by the way, from this autocomplete menu. Sometimes, depending on the world of the website, this can appear for a few milliseconds to up to a few seconds. This means that if you don't handle properly the waiting strategies, your test might fail. This was one of the improvements that we introduced with the implementation of the adapter design pattern. Behind the scenes, when we find elements, we're auto-waiting for them. And then also our adapter, as we'll see in a minute, it contains additional methods like, for example, wait for AJAX requests. And these assertions, all of the pages are implementing the page object design pattern. There are dedicated videos about that. You can find them in the links below. So the page object pattern, just in short, is just a special class that contains all of the elements, how they were located. This is sometimes referred as element map. If for some reason the locator is changed over time, we can go in a single place, modify the locator and fix it. Then in some implementations, these page objects, they contain all of the actions, and in some scenarios the assertions. I prefer to put my assertions in the page objects as well. So we have assertions here for this table for 2 or more products. Instead of providing many parameters, we provide model classes. And we assert the data. Again, for a more detailed explanation about the test, check the first video about the adapter and the proxy. So our second type of test is where we navigate again to the detailed page of the product. We increase the quantity, added it to cart, click view cart. We can increase it from here as well. We check the total. There are tons of tests that can be written here. We're just handling the happy path. Now we're navigating to the checkout page. Again, just 𝐵𝒏𝒕𝒐𝒏 scenario for registering a new account. We're filling all the details here, checking the total, finishing the order. That's it. And we have a regular NUnit project. There is a whole course about NUnit. If you're not familiar, find it on the 𝒏𝒕𝒐𝒏 YouTube channel. Also, there are many articles about that. In short, in C# we install these NuGet packages. These are the dependencies like Maven in Java. So we have these 4 dependencies for NUnit. This is just a standard setup. Also, most importantly, we need the Selenium WebDriver. Also, we have a few other dependencies of Selenium for backward compatibility. If you use version above 4.11, probably you don't need WebDriver Manager, which was before responsible for downloading the proper driver. Now, the newer version of Selenium handle this internally using this new advanced Selenium Manager, and this also they provide this feature for browser management, meaning that if you don't have the proper browser, for example Firefox, Selenium will download a portable version of the browser, which is excellent. And then, as I said, we have regular test classes. We need to annotate them with the test fixture. Before all of the tests, we initialize the driver, we start the browser, and here are our tests. All of the logic, as I said, is moved to these page objects, where we have all of the elements as public properties. If some of the locator needs to be changed, we do it only here. We define these action methods. This is called sometimes DSL or domain specific language, which makes our test much more readable. If we return, you will see that we know on which exact page we are, what we are doing. We just need to provide here the data. That's everything. We have a common class called website where we initialize all of the pages. I usually prefer to have this class so that I don't need to guess what pages do I have. I can just use the IntelliSense here to pick some of the pages. And most importantly, we have the driver adapter. We define this iDriver interface for redefining the iWebDriver interface, where we have these new methods like start or wait for Ajax. We have, instead of find element, we have find component, and inside the find component, as you'll see in a minute, we're out waiting for the elements to appear. This start method, which is called a factory method, we can delay the execution and pick when we want to initialize the driver. So in the actual implementation of the driver, as you can see, the start, we are providing this enumeration. We download with the WebDriver Manager the proper driver. And then in the find component, we are using WebDriver wait, the explicit waits for waiting for the elements to appear. If you're not familiar with the WebDriver waits, you will find the video in the description below. And we are creating this component adapter, which is the improved version of the iWeb element, where we added again new functionalities like type text, or the click method is waiting for the element to be clickable. Also, now the elements know how they are located with the by locator. In short, this was the whole project, and now we can improve it further with the exception analysis. We need to create first this base class, the exception analyzation handler. So let's see how we can do that. I created a folder, another folder for that, and on the analyzation handlers, the first thing is that we need the main goal of our exception analysis is to throw this formatted exception and print it on the console when the test fails. So I created this new child exception, analyze test exception. We derive from the common base class for all of the exception in .NET exception. And the main thing is that we need to provide, we have two constructors just with the message, and if for some reason the test failed already while we executed the test and we have a URL, we can print the URL as well, which will be helpful to know where exactly the test failed. We use this special environment 𝐁𝐢𝐭𝐇𝐮𝐿 to format properly the exception, and in general we'll just have multiple lines and make this more readable. That's it, providing the actual exception message. Next, as I said, for all of our exception analyzation handlers, we need this base class. This can be an interface as well, but I prefer this base class because we provided here some common implementation instead of copy-pasting it. So we have, as I said, we need to preserve the next exception handler in case this one is not applicable. This is the, the core of the pattern. Then we have, since we mark the class an abstract, every specific handler needs to implement the actual explanation message, like, for example, this HTML, not the HTML source, but for example, the service unavailable exception handler. In a minute I'm going to explain how it works, but it provides what we are going to search in the into the HTML, and this is the exception message that we are going to throw. There is a test problem, the page does not exist. This is just one example. But yeah, let's return to the base class. We have an abstract method. This is the core of every specific handler is applicable. So each of them will define a different rule to check. One of them will check whether the URL contains something. The second one will check whether the HTML source contains a particular text. As you'll see later, we'll check whether there are failed requests or whether there are JavaScript exceptions, etc., etc. So every specific handler will implement this isApplicable method in a different way, and it returns Boolean. By the way, we're using here another design pattern. It's pretty simple. It's called template design pattern. So we have an abstract definition of the method, and later we are using it in the abstract class. This is called a template. So in the base analysis class, what we are doing, we are checking, is this handler applicable, providing the exception and the driver. If it's applicable, then this means that we need to throw the specific analyze this exception with the properly formatted message. Again, this detailed issue explanation is defined by the concrete exception handlers. In one case, this will be their JavaScript exceptions. In the other will be, we're not on the proper URL, or this particular string is part of the HTML. But we have two branches, if we have URL and if we don't. This is why we have two constructors in our analyze this exception. And then the most important part of the pattern is that if this particular handler is not applicable, then we need to call the next handler in chain. So we check, do we have another handler? Have we set it using the @exception analyzation handler method? If yes, then we call its analyze method, which will repeat the same logic. So if the first handler is not applicable, then it will call the next one that we added via the @exception handler. It will do the same. It will check again using its isApplicable method. If it's not applicable, it will check the third, then the fourth, and so forth. And the @exception handler, this generic method, what it does, we define it as a generic, and then we have this generic constraint where what we are saying. We are saying this particular type, TException analyzation handler, this class should derive from this base class. That's it. It's completely okay if you implement this as a property instead of a method. It's up to you. I just prefer to do it because in many books about design patterns they use methods instead of properties. So yeah, that's it. Now let's see some actual implementations of the pattern. Maybe one of the most simple ones is the HTML source exception handler. We are deriving from our abstract base class. This means that we need to override the two abstract things, the property and the 𝑣𝒐𝒏𝒕𝒐𝒏. In our case, we override the property, but we are providing the actual detailed issue explanation through the constructor, because we can check for multiple such exceptions or stuff in the source code. This is why I made it this way. Or we can provide them, we can just derive from this class, and as you saw before, for example, this service unavailable, we are just extending the class that I showed you and provided that we are searching for this text and this is our exception message. Or we can directly just initialize this particular class. It's up to you. So what we are doing in the 𝑣𝒐𝒏𝒕𝒐𝒏 method, again, this is the core method that every handler should override. We are checking, do we have a driver? Yes. If yes, then we are going to get the HTML source and we'll check with the contains method, because this is just a string property, whether the source code contains the text to be searched for. And we are going to return the Boolean result. If this is applicable, again, we will go inside this clause here where we are going to throw the analyze test exception. We're going to throw it, then no other handlers will be called, our test will fail with the proper detailed explanation. Otherwise, we continue with the rest of the exception handlers. One of them might be, directly checking for this one. Or another similar one is, as I said, if we are logging into the application, we usually, if the login is successful, then we will navigate to the account page, for example. But if for some reason we are not on the proper page, then we can check for whether we are on the specific URL or not. So instead of checking the HTML, whether it contains a particular string, we can check whether we are on the exact URL or not. So as you can see here, we are checking whether a particular part of the URL contains something or not. This is another handler. What else? As I said, we can check for service unavailable. We can check for, we can have more advanced handlers here. But in order to do that, we need to implement some more advanced Chrome developer tools or bidirectional APIs to our driver adapter. So let's see how we are going to integrate the handlers and how we are going to extend the driver to have access to all of the requests, all JavaScript exception messages, to all console logs, so that we can create all of those additional, for example here, this performance metric, we need to capture the metrics and check them. So let's see what we are going to do. What else? Actually here we are going just to return true, otherwise we're going to return false in a minute. I'm going to explain what we're doing here. But now, what changes did I did to the iDriver interface? I added a few new methods that are here. First, we need to have a method capture metrics. These are the performance metrics of the browser, like you're going to see them in a minute, but basically we can check for memory leaks, we can check for the performance of the page and many others. We have two properties of lists with JavaScript errors and console messages, and also we have two collections with concurrent backs. The concurrent back is a special .NET collection that it's thread safe, allowing us to, if multiple processes try to insert requests or responses, there won't be any deadlocks. This is the whole reason. So if we look into the driver adapter, I'm going to explain in a minute how we actually incorporate the exception analyzation handler and how we call it, how we initialize it, how we do that. So for the network, for the dev tools, for JavaScript engine, we have these three new private variables here. In the start method, we have a lot of new logic here. First, again, if you're not familiar with bidirectional APIs and Chrome developer tools, they're like very comprehensive course on the Lambda Test YouTube channel. Check it out, where I discuss each of these new features in many details and examples. And you can check the exact syntax. I'm not going to explain the actual syntax because you can check it in the official Selenium documentation. So we initialize the JavaScript monitor, this JavaScript engine. We have two event handlers that we are initializing. So we are adding, if there are any additions to the console from JavaScript code, we're going to add them to this list collection. Probably it might be a good actually to update that to concurrent back as well, because it's possible many process to try to create and walk to the console. The same we do if there is a JavaScript exception thrown. This monitor will throw this event, and we are subscribing to it, and we are saying if there is such a message, JavaScript error, please add it to this particular list that we are going to check later in the specific handler. And we need to say start monitoring. In order to be possible to call this await asynchronous method, I had to modify our start method. Before it was void. Now I used I made the start also asynchronous. This means that I put here the asynchronous keyword, and now instead of void I'm returning a task. This is the way we do that in C#. Next, for if our browser is Chrome or Edge, this is only for these two browsers we can use the Chrome developer tools, as you can guess from the name, because both are implementing this Chromium driver and the Chromium engine. So we initialize the DevTools. We enable this command. This enabling command is for be able to capture performance metrics. And the next thing that we do is that we initialize two handlers for network requests and for network responses. If there is a new request or a new response, we are going to add it to the both collections that I showed you before. So we are initializing this network interceptor, and it has two methods, add request handler and response handler. I know that the syntax is a little bit different depending whether you use Chrome developer tools or bidirectional APIs. At some point, everything will be migrated to bidirectional APIs that are browser agnostic. So we have these add request and response handlers. We added this, and we need again to await and start monitoring for such requests and responses. We also have this additional method for capturing all of the metrics. So we send this command, get matrix command here. I know it's a little bit strange how we do that in .NET. It's a generic method where we need to provide the settings and the response, and here we are providing the settings again. If there are any metrics, if there are any metrics, we return them here as list. Otherwise, we are returning an empty list. In case, you know, for example, if you used Firefox or Safari. And then how we use actually the handlers now, before we check the actual specific handler implementation. We use the special class called event firing WebDriver. In Java, this is event firing WebDriver listener, I think. So this event firing WebDriver decorator, it gives us these events here, and we are subscribing to this event. There are other events like, for example, when the element is clicked, or element is clicked, checked, value changed, when the element is found, etc. However, we care now only about when there is an exception, when our test failed. So this is where we subscribe, and we call our primary exception handler, and we call its analyze method, providing the actual exception. What is this primary exception handler? This is the first handler in our chain, and after that, if the handler is not applicable, it will call the next one, and the next one, and the next one. Here is how we initialize them. I modified the constructor of the driver adapter to accept you know, one of the handlers, and in this private method initialize exception analysis handlers, I'm initializing all the handlers that I want. This can be directly in your test, it can be in some special place depending on whether you use NUnit, MS test, or in Java it's something different. Just to make our test easier, I put that in our test class. So the thing that we do is that in our primary handler is the console warning handler. In a minute I'm going to show you how it works. We check just the collection whether it has any console warnings or not. Then we create a second handler, and we call the first, and then we connect them. How we connect them? The first handler, we call its at exception analysis handler, and we provide the second. Then of the second handler, we call its at exception and add the third exception handler. For the third, we add the fourth. For the fourth, we add the fifth. And this is how we chain them. This is how actually, if you know how the linked list works, this is pretty similar, by the way. So let's see the actual implementation now. For this new logic that we added for the console, we have this JavaScript console warning handler. So we are deriving again from our base abstract class. I made this class abstract because we want to check for different warnings inside the console messages. But the important part is here. Actually, we check whether the particular text to be searched is part of the console messages list that we defined before. Again, just to quickly remind you, we initialize this list here. This event, it will be called when a particular JavaScript code writes to the console, and we are going to fill this console messages list. So I have a console warning handler where I'm checking, actually maybe the proper term here is outdated console warning handler, where we check if there is a warning called outdated. We're going to mention that there were some console warnings about outdated libraries. We have something similar for JavaScript errors. I'm saying here the detailed issue explanation is there were multiple JavaScript errors, check console logs for more explanation. And in the is applicable, what I'm doing, I'm logging all the JavaScript exception messages to the console, and after that the check is if there are any JavaScript exceptions called by the event handler part of the bidirectional API, then we are going to fail our tests. We are doing something similar for this failed requests handler. If there are any responses that contain failed requests, then we are if there are any error codes, then we are going to fail our test. And the last one is about the performance. I created this more abstract performance metric handler. If you print all of the metrics, there is a comprehensive list here, but maybe some of the more meaningful one are navigation start, DOM content loaded, first meaningful paint, and maybe this total heap size. By the way, this total heap size, in some cases in projects that I was part of, using this metric we managed to detect memory leaks in a single page application, so it's very meaningful to check it. If it's above particular threshold, so we are getting the particular metric by name, we get its value, and if it's above the threshold that we specify through the constructor, we specify here the metric in the name, we will throw a detailed exception where we will say this metric is above the threshold that we mentioned. If we don't want to specify every time in the constructor, for example, we can create a detailed child class of this performance metric handler where I'm specifying the name of the metric and the threshold here. And again, the way we use it, we can use directly the specific child classes, or you can use directly the more customizable classes where we directly through the constructor we provide the actual messages. It's up to you how you are going to reuse them or not. It can be just some specific handlers for your particular application. But again, the main thing is that we are chaining them here by hand. We are connecting them one with another. The driver adapter only knows about the first one, and then after that we are calling if this handler checks if it's applicable. If it's not applicable, by the logic provided in our base class, we're going to call the next one. The next one is going to call its own is applicable. If it's not applicable, it will call the next one that we connected to it, and so on and so forth until we are out of handlers. So this is our comprehensive solution for troubleshooting exception messages. As I said, this can save, this is maybe the most time consuming depending on the complexity of your framework and the code quality, and when the test failure is more accurate and understandable for people who didn't write the tests, I believe the required time for this maintenance will be decreased. And this is why we picked the chain of responsibility design pattern, because it's a good fit for the job, because we needed an algorithm similar to the exception handling in Java and in C#. So in the next video we are going to discuss the strategy design pattern, where we are going to further extend our mini test library or a framework, where we are going to use the strategy to create more customizable ways for waiting and finding elements. So stay tuned. Thank you for watching. If you have any questions, put them in the comments below. I will be really happy to hear about your opinion about these examples. If you have another favorite pattern that we are not covering in this course, put your wishes in the comments below. Check the Lambda test blog for much more detailed articles, and don't forget to get your free Selenium JUnit and other certifications on the Lambda test website. Thank you for watching, and see you in the other module. Hi guys, greetings from Bulgaria. In this video we are going to cover the strategy design pattern. This is part from our course about design patterns in automated testing. I say in automated testing because we are looking into original design patterns that are used in regular programming and how we can apply them in our context of automated testing, sometimes a little bit changing how they work. So in the first module out of this course, we looked into how the proxy and the adapter can help us to improve the interface of iWebDriver and iWebElements. We added new functionalities to them, and we improved the maintainability of our tests. Then we covered the Decorator design pattern that added extensibility to our mini-test framework. Then we discussed the Singleton that helps the API usability, or how we use particular functionalities such as factory repositories, page objects, and others. We covered dependency injection that can add a lot of flexibility to our mini-test framework using inversion of control containers like Unity. We discussed the chain of responsibility design pattern that help us to build advanced troubleshooting functionality to our mini-test library. And now we are going to cover the strategy design pattern that will help us to define different algorithms that can help us to extend further our project, adding flexibility to add new locators, how we locate the elements or how we wait for them. Also in the links below you are going to find a link to the GitHub repo so that you can clone all the examples and you can play them along with the video and test it later. Also, you are going to find many resources that you can use, like articles, etc. If the pace is too fast or too slow, you can slow or increase the speed of the video, and also you will find jump links if you want to watch just a particular part of the video. If you haven't subscribed to the channel, please do so. Hit the ring bell so that you get notified when new videos are published to the Lambda Test YouTube channel. Many awesome videos about best practices are published each week. Also check the Lambda Test blog where you're going to find many advanced articles about the best practices in automated testing. And now let's get started. First we're going to define the problem. Really quickly, since I'm going to try these modules to be independent from each other, I'm going to give you a quick refresh of our project, what we are automating, and what we have until now. If you are curious, you can check the previous videos, especially the one about the adapter design pattern, and you're going to find it on the Lambda Test YouTube channel. Also, I'm not going to write all of the tests that we are going to refactor from scratch. We did that in the first module about the adapter, but now we are going to extend and refactor this solution when we discuss the strategy design pattern. So let's get started. First, I'm going to give you a quick refresh about our tests. Many often during this course, I'm repeating every time that if our tests or solution project that we have needs to be simplistic, our test is simple, probably in most of the time you don't need design patterns. Design patterns are for cases where we already have really complex scenarios, logic, cases, tests, and then we need to apply the design pattern so that we don't be in the position of a nightmare of a maintenance where we just maintain the tests instead of writing new tests. So our first scenario that was a little bit more complex was that we were searching for a product here. One of the things that we improved with the adapter design pattern was that when we see this particular autocomplete, in particular scenarios, this can be pop up in 1 second, but in others, when there is a significant load on the website, it can show up for much more seconds, and then we need a smart wait this to wait for it, otherwise your test will fail. So if you're not familiar with explicit waits or the smart waits in Lambda tests, you can check those videos and you will find them in the description below. So we basically, using the adapter, we improved the iWebDriver interface in a way that you're going to see in a minute, where we where this logic is hidden, right? How we wait for the elements. So the next thing of our test case is where we come at these items to be compared. Then we search for another item. Again, we write all those tests in a way that we use page objects. Page object model is a very popular design pattern. Again, there are a lot of resources on the Lambda test blog and channel. But in short, one page object is one class. This is the simplistic way how you can write that. So in this class we have all of the elements, how they are located, all of the actions that we can do, defining the so-called DSL or domain-specific language, making our test much more readable, because there can be read, the code can be read like sentences. And in some versions like mine, I like to put my assertions that we do on the page in the page object. Again, if you're going to reuse those assertion methods. And another thing that can increase the maintainability of your test is that if you don't use too many parameters, but instead if you use model classes, those model classes are just simple classes that contain all of the data that a particular method will need. So as I'm going to give you this refresh. I wrote these functions in a way that, for example, here we need to verify all of those information, all of this information, and we provide the expected results as a model classes. And the logic works in a way that we can add 2 but many more products, and this will continue to work. And we use XPath access here to find those particular rows in the table using more advanced XPath. There is a dedicated, very advanced article on the Lambda test blog about how to write those more advanced XPaths. So this is the first use case. Then we have we can add our second test is where we add products to the shopping cart, clicking add to cart, then we click view cart, and we can increase the quantity, refresh it, and we are just verifying the total. You can write many more tests here to verify various things, but we are just keeping it simple and automating the happy path. Then we check out, again, just the happy path, filling the information here, verifying the total. We click terms and conditions, continue, that's it. And if we check the source code, again, you will find a link to the GitHub repo in the links below. This is a standard NUnit Selenium project. In C# we use the latest .NET, and like in Java where we use Maven, here we use NuGet packages. I installed all of the necessary NUnit NuGet packages here, the latest version. We also have the latest version of all necessary Selenium NuGet packages. The most important one is Selenium WebDriver. And if you use version 4.11 and above, probably you won't need, for example, the WebDriver manager and some of the rest. Since now Selenium WebDriver includes its own Selenium manager responsible for downloading the proper drivers, and even it includes browser management, which means that, for example, if you don't have Firefox, it will download a portable version of Firefox and it will execute the test, which is really awesome. And then we have in this particular solution, again, our tests are inside those NUnit test classes that are annotated with this test fixture attribute. we use these test init methods annotated with the setup attribute. These methods are executed before each test, where we initialize start the browser. If you want to execute your test in Lambda test, here is the place where you're going to provide all of the capabilities, or later in the version with the adapter, you're going to place that in the start factory method. After each test, we are closing the session so that you have, for example, in Lambda test, a separate video about each test, and then we use the page objects to automate the different scenarios. That's everything. Inside the page objects, we have a base class where we call the reference to the driver using composition to the driver, WebDriver weight, and actions. And as I said, every page object contains a lot of public properties to the different elements here, where we provide allocators. If a change is needed, we can apply it in a single place. And we have all of those action methods and assertions. In the adapter version, we have the actual adapter. We have also adapter interface that specifies how the adapter should look like. We added new functionalities such as the start method, where we basically initialize the driver. We can postpone when we start the browser with it. Also, we have more advanced, improved find component methods, where we wait for the element to exist and then we return it. But we return the specialized version called component adapter, which is a wrapper to the iWebDriver interface, again providing additional functionalities. Here, for example, we have wait for Ajax, waiting for this asynchronous JavaScript, and all of those additional requests to finish. And this is the actual implementation, the driver adapter class, that in a minute we are going to refactor using the strategy design pattern. As I said, in the start method, we are using the WebDriver manager. Again, if you use the newest versions, you don't need it, but we initialize the drivers here, and the magic is happening here in the find component, where we first use the explicit waits, the WebDriver wait, to wait for the element to exist, then we wrap it in the component adapter and we return it. And the component adapter, similarly to what we have to the driver adapter, we added new functionalities, such as now the elements know how they were located. Also, for the click, we are waiting for element to be clickable, or we improve the type text. Instead of every time calling clear and send keys, we have a single method called type text. This is in short. And now let's review the strategy design pattern. So for the strategy, this design pattern, it enables an algorithm's behavior to be selected at the runtime. As you'll see in a minute, we'll be able to define different find strategies, because right now we use the native way where we use this static class by with the predefined Selenium native locators. And in a similar way, in other frameworks like Playwright, they're not built really in a way that you can easily add different locators, but instead I'm going to show you how we can use the strategy design pattern to simplify that. So here our algorithm can be, for example, finding the elements or how we weight them, or even you can use a strategy for let's say the shopping cart that I showed you here. We can define different strategies for the different workflows here. That's completely fine. We can refactor our test to use strategies for that. This design pattern is one of the simplest that we are going to discuss during this course, because basically we have an interface or an abstract class that it's base for all of the concrete implementations of the algorithm. It's called strategy. As you can see here, we have a method run algorithm. This is just for a placeholder. In our cases, this can be named differently. In one case, this can be a find element, or in others can be wait. And then we have the concrete strategies, the implementation of the strategy itself. But the users or the context of this strategy, it always references the strategy as the base class or the interface, so that we can change the algorithm later providing and simplifying the concrete strategy, as you are going to see in a minute. So let's see how we can refactor our current solution. As I said, here the drawback of our current implementation is that we are limited to how to this static by locator. If we click here, go to implementation, let's see whether we'll be able to see that. Go to implementation. It's actually in the Selenium. Yeah, all right. So anyhow, if we open it, you're going to see, yeah, here it is. Sorry. If we look here, you will notice that this contains a lot of static methods, this by ID, by XPath, etc. It will be extremely hard for you to add new locators such as ID containing, ID ends with, or link contains, etc. Or even in some projects we add such locators like finding something by label, or you can in the modern web frameworks such as React or Angular, you will need additional locators for React or Angular specific attributes, right? So we can use the strategy to define an easier way in your mini test library like ours. So let's see how we can do that. I'm going to create a new folder here called locators. Now, after that, we need to define, if we return to our diagram, we need to define this base class for all of the different strategies. In our case, I'm going to name this class find strategy, right? And this find strategy, let's just copy the namespace. Here we are going to change that. We don't need these usings, and I'm going to make this public abstract so that next we need a property that can be a string property that can be named value. This will hold the actual value of the locator itself, for example the actual XPath or the actual ID or the actual part of the ID, and then we'll have a method that we will need to define in the concrete strategies. This is why I'm going to mark it as abstract, and this method will return the actual by locator converted. This will be the native by. However, every strategy will have its own way in this convert method. This convert method will be responsible for example, if you have ID containing, inside of the convert, we can use specific CSS or XPath for doing that. And after that, of course, we need a base constructor of this class, like here. This is why I'm making it protected. And let's now create the first simple strategy for that. I'm going to name this ID find strategy. Here I'm going to change the namespace again. I'm going to clear that. I'm going to make this public, and of course we are going to derive from our base class, if you remember the diagram, and we are going to implement the abstract class, and we will need a constructor like this. Visual Studio is generating those for us. When you click Alt Enter, and it gives you those suggestions. Basically it did it for us. So here, since this is just the base strategy, that it will be the same like we do in the regular WebDriver, we are going just to return by ID, and here we are going to provide the actual value part of the base class. For now we haven't added anything, we just made something simpler, a little bit more complex, but in a minute you're going to see the actual strength of the pattern. Now I'm going to copy paste it like that. I'm going just to rename it to XPath find strategy. Again, here we will define strategies for all of the standard locators part of the Selenium, like XPath, CSS, tag, link, inner text, etc. I'm not going to do that in order to make this shorter. But now let's see what we can do if we want to create, for example, a new locator called ID containing. Containing find strategy. So in order not to, just watch me how I type code, I'm making this more quick. So I'm going to rename that to ID containing find strategy. Now, how we are going to implement that? Of course, we need to change that. In cases where I can choose between XPath and CSS, usually I pick CSS selector because it's a little bit faster than the XPath. So in this case, we can use CSS selector. So I'm going to use string interpolation. String interpolation is another way in C# that we can easily format strings, but you can use just regular string format. And here we are going to generate a unique CSS selector, ID star equal, and then we use single quotes. And then in the string interpolation, when you use curly brackets, this will be changed later with actual, this is like a placeholder that will be exchanged with the actual value part of the value property. And this will build every time a unique CSS selector for ID containing when we call the convert method. Excellent. And let's see one more example. For example, for link, it can be inner text contains. That's fine, right? Inner text contains find strategy. Please note that every time when I use patterns, I use the suffix strategy, and the names of the pattern, they use like a shared vocabulary for us between programmers, and when they see strategy, they already know what is the logic behind it. They know that when you use the proper word and name strategy, they know that this is interchangeable algorithm and know how this works. This is why design patterns beyond their high value in reusing algorithms and logic can be used as a shared vocabulary for you easily to orient in someone else's code, which is excellent. So here, instead of using CSS, this time I can use XPath, again using string interpolation. Let's delete that. And I'm going to start the XPath locator with 2 slashes, then I can use star, which means any element. Then we can use XPath methods like contains. I'm providing brackets since this is a method. Then we use another method called text, then comma, another parameter. In this case, this is the actual value. In XPath we use many often single quotes, and then we are going to provide the placeholder for the value attribute like this. Again, you can repeat that for as many strategies as you want. Now we will need to build. Of course, you can directly implement that directly in the adapter, but we're going probably we will need a logic like some of the methods to be used inside the driver adapter, but also in the component adapter, since here we have also find component methods, right? And as part of the iDriver interface now, if we are going to use the strategy, we want, instead of providing here the regular by native by class of WebDriver, now I'm going to comment that, and I will want to have additional methods like that. In a minute we are going to create similar strategy for the weight. I don't have it now, but we will have separate find methods for the different strategies. At the end of the video I'm going to show you how, if we build additional strategies beyond those declared here, I'm going to show you two ways using extension methods and another way using partial classes, how we can add additional such methods here. Of course, you can have just a method like this, where every time we need to provide the find strategy. But again, this is, you know, my least preferred way, because every time you need to, you know, type new find strategy, something which is too verbose, in my opinion. Yeah, if you need to type it. And this is easier when you use autocomplete to find properly. You're going to type it just a little bit faster than typing find, then bracket, then by, then dot, then bracket, then something. Not bracket, but dot, a particular method, right? This is why we are going now to change how this iDriver works. We will need, again, click Alt Enter, then click Implement Interface, or you can click directly on this bubble. And now we have all of these placeholders with not implemented, where we will need to implement those methods. But instead of repeating the code, since we can search in the browser itself, but also remember that you have find methods here, and I don't want to repeat the logic with the find locators. This is why I'm going to create another special class called, for example, we can name it like component find service. This is a class that will find components, right? Let's copy the namespace, and the way this works is that we're going to have two private variables. This can be internal, but also it can be public. It will be up to you. Here I defined a private variable to the search context. Why I have here search context instead of 𝐴𝑤ebDriver? Because 𝐴𝑤ebDriver and the 𝐴𝑤ebElement, both interfaces, they implement this iSearch context, because you can search inside the browser, but also inside the element itself. This is the iSearch context. And I implemented these two methods. In a minute I'm going to show you how this works here with the weight when we define the weight strategies. But yeah, here we define two methods. One of them will return the native 𝐴𝑤eb element. It will return the native 𝐴𝑤eb element, and it accepts the base class for all strategies, so that we can provide any of the concrete implementations here, right? And the same for find all. And we are going to use this component find service inside the adapter for the driver, and inside the adapter for the component itself. So let's see where we can add those. We will need to add a private variable to this service here at the top, and we are going to initialize it inside the start method at the bottom. So we have it here, and next I'm going to comment these two, because we are not going to use them anymore, but we are going to use the new specific find methods, right? And we will need two maybe private methods. It will be up to you whether they will be private or not. Actually, we are going to implement these two here, find and find all. Let me show you how they work. Instead of typing the code, let's do it like that. So here, this find method, if sometimes we we are not using extension methods or partial classes that we are going to discuss. If you want to use your custom find strategy that it's not part of this mini test library, you can provide it here and this will start to work. You cannot do that with the by, because with the by you have just static methods that you cannot add more, right? But with the find strategies, that's completely fine. We are changing the way, the algorithm, how we find different elements. So we call our internal component find service, we call our find here, inside it will use this convert method to return the native by, and then we wrap it inside the component adapter. And here inside our component find service, we are going for the element to exist. Now if we need now to define, for example, how this find by ID works, let me show you. We can directly write it like that. Find, this will call the other global public find, where we can use it like that, but why? We can just use find by ID, which is simplifying the way this works, right? And for the XPath, similarly, we can call return find new XPath find strategy XPath. That's it. And you can complete and implement the rest of them. It works similarly. Now, instead of typing everything, let's quickly show you how we can achieve the same, but for the weights. For the weights, we can define a new folder, weights. And inside these weights, we can define another abstract class called weight strategy. In this weight strategy, again, we can just get the namespace. It's up to you. Usually I make them public so that you can use them later inside other projects. And here I'm going to define a protected constructor and two public properties to be able to change the timeout of the WebDriver weight and the sleep interval. Then we are going to define one abstract method that every weight strategy needs to implement. This will be the abstract wait until, where we need to provide the actual search context, the iWebDriver and the by, and then we'll have a few protected helper methods that we can use in our concrete wait strategies, like wait until that accepts a delegate or a function or a lambda function. It's up to you. We can actually make this more maintainable, initializing it once in the constructor, but it's up to you. And then we have another helper function here for find element. And if we need now to create, for example, to be clickable wait strategy, we can create another class similar to the find strategies. We need to get here again the namespace, and similarly to what we did, we are making this public. It derives now from wait strategy, which is the base class. We click Alt Enter, implement the abstract class, and we will need first, of course, the constructor that basically provides the same parameters and calls the base constructor of the base class. And then we'll have one helper private method here called element is clickable. We'll provide that to one of the helper functions part of the base class, like that. Again, here it's not important how this internally works. In short, I'm going to explain it. We have anonymous lambda function here that we first find the element using the protected find element method part of the wait strategy base class, and we check whether the element is null and whether it's enabled, and we are turning true if it's clickable. That's it. We can do that, and I'm going to show you the same how this works for to exit strategy, to be visible, etc. As part of folder 3, you can find the rest of the strategies here that I defined. For example, we have similarly another weight strategy for, we implement it the same way. We have the concrete weight strategy. It derives again from the base class. We call again the base constructor, providing the different timeouts and sleep intervals, and just the internal function here is different, where we check that the elements is not null. But for example, to be visible strategy, it works the same way, but instead of checking the enabled property, we are checking whether it's displayed or not. And if we look into the adapter, we can search for the weight method here, and we have the, as you can see here, we are providing the actual component, the actual weight strategy. We call the wait until, providing the drivers and the component by, and this will wait for us. The way we use that is as follows. Here we'll call driver, let's see where we have that. Okay, we have the driver, so we'll call here driver dot wait. Then we'll provide the view card, and then we need to provide the actual strategy. So one way to do that is if you type new to be clickable wait strategy, but the same way, instead of to be clickable, we can provide to be visible, right? Or if you have another one, you can provide a new one. It's up to you for what you wait. You can wait even for another element to appear, or you can wait for, I don't know, for all of the AJAX requests, or for all React requests. It will be up to you what you wait for. However, instead of using this syntax with the new, I implemented another class called wait, where we have this static to property, and it's implementing another syntax for the same. This is a simplistic factory class, where we basically, the factory class, as we will discuss in the next module, is responsible for creating stuff for us. In this case, this will be this wait strategy factory that creates, initializes, and is reusing how we initialize all of those strategies instead of using the new way, the new keyword. And in our case, this simplifies how we use it instead of using the new syntax, but it will be up to you. And now, if we want to add additional, if we create in another class that it's referencing our core project, if we now want to create another locator like ID containing fight strategy, one way to add this to the driver adapter will be to use extension methods. And these extension methods, how they work is basically we wrap them in a static class. In this case, this is called driver adapter extensions. Then we have a static method, and we need to specify first, as a first parameter, what we are extending. In this case, we are using the this keyword. This will be the interface of the driver adapter, the iDriver. And when you add a using to this particular class here, like here, I can add the using to my extension methods using extensibility demos. From now on, I will have find by how was the name of that? Create. Okay, it's just another name. But yeah, if we go to the card page, I will now have create. Oops, not here, sorry. We'll have it here. Driver create 𝑨𝒏𝒕𝒐𝒏. This is one way how you can add that. It will be like this is really part of the actual interface. This is excellent. Another way how you can add such an extensibility is if you make your component adapter, driver adapter, a partial class, and this opens this particular class. If you create a similar partial class in your referencing project, you can add additional methods to it. That's another way how you can build that. It's excellent. So we covered the strategy design pattern. I think this is a really excellent way for extending the libraries. We refactored our solution. You saw a few ways how we can add new methods, new find strategies or wait strategies. Again, many times this is necessary in more complex scenarios where you need to automate React, Angular, or find something by a custom label, right? So we saw how we can use the strategy design pattern for that. We use it extensively in our enterprise project as well, and the frameworks that we develop. It's an excellent design pattern, and it goes beyond this extensibility of the test framework. As I said, you can use it as well in your automated tests in page objects to define different workflows, like in the case with the Lambda test playground. In the next video, in the next module, we are going to cover the repository and factory design patterns. They are used many often together. This is why I combine them in a single module. You already saw a few examples of the factories. So the factories, we use them in short for initializing test data or creating classes and initializing them. And we use the repositories for wrapping the logic for making requests or calls to the database. And we are going to use those for creating test data. And this is really important things to know for the proper test data management of your automated tests. So check it out later. Thank you for watching. If you have any questions, put them in the comments below. I will be really happy to hear for what design pattern you want to hear next. Check the Lambda test blog for many other detailed articles about best practices, and don't forget to get your free certification about Selenium, JUnit, NUnit, and many other technologies on the Lambda test, part of the Lambda test certification program. Hi guys, greetings from Bulgaria. In this video we are going to cover the repository and refactory design patterns. In this course about design patterns, we already covered 6 of them. If you missed some of them, please check the Lambda Test YouTube channel. In the first module, we covered the proxy and the adapter design patterns that help us to improve the IOAP element and iDriver adapt interfaces, and we added new methods to them and also make our test much more stable. Then we discussed the Decorator design pattern that help us to bring extensibility to our mini test framework. Next, we covered the Singleton, which improves the API usability and can be further improved the page object patterns, the factories, the repositories, and others. We covered also dependency injection, very popular for testable architectures, but also can be used in test automation frameworks. We covered chain of responsibility, which help us to bring troubleshooting features to our mini test library. And we cover strategy, which is awesome pattern for automated tests where we were able to extend our mini test framework, allowing our clients to build new locators and waiting strategies. So in this video, in a minute, we're going to cover the test data management in our automated tests, making them much more isolated and stable using the repository and factory. If you haven't subscribed to the channel, please do so, hit the ring bell so that you get notified about many new awesome videos that are published each week. Also check the Lambda test blog because there are many topics covered there about the best practices in our modern world in test automation. And in the links below you will find all of the available resources to GitHub repos about the 2 design patterns, also one for the demo application that I'm going to use, and you can play with them along with the video. Also, you will find some snippets there so that you can jump around with those links between the different topics covered in the video. And yeah, so let's begin. First, we're going to define the problem. We're going to cover the repository design pattern and the simple factory design pattern. There are other factory variations of the factory design patterns that are out of the scope for this particular module. And let's begin. In one of my books, I covered, in my 3rd book from the test automation, automated testing unleashed, about API web testing. The 4th chapter was dedicated, as you can see here, to SQL and databases, access to databases. So why this is important? Before that, let's jump a little bit to our demo application, and I will return to that. As I said, in the previous modules we used the Lambda test playground, right? But since it doesn't have web APIs, we use web APIs for extensively for test data management, as I said. And since we don't have that, I built this custom application. It's built on Node.js. As I said, you can find the link to the GitHub repo in the description. And it's based on this very popular free database on SQLite. It's a database for a music web shop. Basically, in this populated already with data database, you have tracks, you have albums, you have artists, you have employees, customers, invoices. It's excellent. And I wanted to create a website around it. It's built on Node.js, and let's see it here. So yeah, in this Node.js application, there are 2 important files. One of them, of course, it's just a single page, but it's very long. We use here Bootstrap, and then at the bottom you will find many JavaScript functions for fetching the data for the different data grades, as we'll discuss in a minute. And then we have a portable Node.js server here. All of the code is present in the server.js, where I defined all the endpoints for exposing this database to the front end. We have, for example, queries to get all of the artists, to get an artist by ID, for example, as in a minute we're going to discuss, there is a search functionality, etc., etc. In order to use the application, you just navigate to the folder of the cloned repo and type node server.js. You just need to have pre-installed Node.js. That's all. And then the application that we are going to use, as I said, is basically it has 2 views. One for the artist is just a view where with the table I have all of the artists from the database. I added functionality for adding a new artist. We have an update, delete, and for each artist we can display all of related albums and in each album we can view all of the tracks. After that we have a more sophisticated view for all of the customers, again displaying all of them. We can add a new customer. As you can see here, there are a lot of properties and we have validations for them. Similarly, we can update the view, we can delete them, we can display all of the invoices related to the customer and view for each particular invoice all of the items part of it with all of the prices here. And we can view who is the responsible employee for this particular customer. And here the sophisticated part of this functionality is actually the search. At the end of the video we are going to automate that. It's not just like this simple search here where it's basically searching to the names and containing the letters here, but also here we can chain more sophisticated conditions, like we can use and, or, nor, and we can bring together a few and search by a few columns. So we are going to create separate tests for the API, and we are going to automate it through the front end as well. Now, if we return, let's now discuss the repository design pattern. So the repository design pattern is a widely used design pattern that abstracts the way objects are stored and retrieved and manipulated from the database in an application. It acts as a middle layer between the business logic and the data mapping layers, effectively hiding the details of data access mechanisms, and this pattern is particularly useful in applications with complex domain models, as it enables developers to work with a more object-oriented view of the data rather than dealing with SQL queries directly. And as I said in my third book, part of Automated Testing Unleashed series that contains 5 books, there is a chapter about SQL. And here this is a .NET project, console SQL-wide. This is the representation of all of the tables. For each table we have a C# class. Each column is represented as a property. And here we use a popular framework, ORM, or Object Relational Mapper, entity framework, to write and make all of the queries. So for this query we are writing a similar query using C# and LINQ. There are 2 alternative syntaxes. And back to the repository, here I added one interface. In C#, implementing the repository pattern typically involves defining an interface like this one that specifies the operations that can be performed on a particular type of entity. This can be the customer, the email, the employee, right? And these concrete classes that implement this interface provide the actual data access logic using the underlying data access technology. This can be this entity framework ORM or Dapper or something else. And this approach decouples the application's core business logic from the specifics of the data access technology, making the code more maintainable and testable. And the same goes to our automated tests, of course. If we want to make an access to the database, or as we will discuss, we can use similar approach for making the HTTP request to our backend. We can create an implementation of this interface similar to, I don't know, maybe this class. Concrete repository, we are implementing the iRepository interface, replacing this your entity with, I don't know, maybe artist. Here we're accessing the data context. In this case, this is the database. Again, we're not, most of the time nowadays, we are not working directly with databases, but instead we are using the microservices or web APIs to access all of those CRUD operations. CRUD stands for create, remove, update, delete, right? So usually we have get all to get all the entities, we have get by ID, we have insert or add, we have update or put, and we have delete. So this is the variation for the database, right? Now let's return to our code that you can, as I said, clone from the links below. I'm going, for our examples, to create wrappers for our web APIs. And this pattern can be adapted or used in scenarios where you are not directly interacting with the database, but instead calling a REST web API. However, when the data access mechanism involves calling a REST web API, in some cases a more specific pattern or architectural style might be appropriate. For example, the API gateway pattern or the so-called client pattern. Let's quickly just review them. The API gateway pattern involves implementing a service that acts as an intermediary between your application and external web APIs, in plural, APIs. This gateway will aggregate the results from various service calls and handle errors. And potentially cache the responses for performance improvements. While it doesn't strictly replace the repository, it can complement it by abstracting the complexity of interacting with multiple microservices or external APIs. Most probably in your automated tests you won't need such API gateway pattern, but it's good to know that especially in systems with many microservices, this can be useful. And alternatively, a pattern that specifically deals with consuming external services or APIs is often referred to as client pattern. So instead of calling this artist repository, we can call this artist client. And this pattern involves creating client classes like, for example, artist client, customer client, album client. And those client classes, they encapsulate the logic for accessing services exposed by the REST APIs. This encapsulation allows you to isolate all the HTTP request constructions, as we will see in a minute, the response handling, the error management in one place, making the consuming code cleaner and more maintainable. Now, calling your wrapper an HTTP repository can be appropriate if your wrapper is designed to abstract the complexities of the HTTP communications while presenting a simple interface for performing these CRUD operations on entities as if they were being directly managed in a local data store. This naming aligns well with the repository pattern. This is why I'm going to use this particular name, HTTP repository. And yeah, on the other hand, naming it client is also suitable, especially if the wrapper's functionality encompasses more than just CRUD operations in some cases. The term client broadly indicates an entity that consumes services provided by another system or component. In many instances, this is the RESTful API. And align with the naming conventions used throughout your project or within your organization. Consistency helps in reducing the learning curve for new developers and maintaining a coherent code base. And it's good to know that there isn't one size fits all answer to this question, how to name it. But again, I will use this particular name. Now, let's review it. This is a simple NUnit C# project. Let's review it quickly. If I click Manage NuGet Packages, here I installed all of the required NUnit dependencies together with the Microsoft .NET Test SDK. If you're not familiar with NUnit, there is a whole series in a course published on the Lambda Test YouTube channel. Check it out. Also, I have installed all of the Selenium dependencies Some of them, like the WebDriver Manager, are for backward compatibility. If you are using Selenium version 4.11 and above, you won't need the WebDriver Manager, since now Selenium provides the Selenium Manager, which is responsible for downloading the drivers and also provides browser management, which means that if you don't have, for example, Firefox, it will download a portable version of it. And very importantly, we need these two packages, 𝑟est-sharp and 𝑟est-sharp serializers .NET Newtonsoft JSON. This library 𝑟est-sharp is very popular in the .NET world for making and dealing with REST web APIs. It's something similar to REST Assured in the Java world. Now, let's return to our example. I created first, we have model classes. What are the model classes? They are really important for the serialization and deserialization of the responses. Here, I called my endpoint API employees to get all employees from the database. And as you can see, the response here is an array of JSON objects. Each JSON object here contains the different properties. And if you take a closer look, we will have a similar C# class for the representation of one of these nodes, right? We'll have an employee class that will have a property of integer called employee ID. We'll have a string property called last name. We'll have another one, first name, etc., etc. And we'll do that for all of the different JSON's representations of each of the tables from our database. I already created that. There are tools that can automatically generate those for you, especially maybe in some companies you have a predefined SDK for that already your developers did. It's good to check with them. And probably the SDK will provide similar clients or repositories, HTTP repositories for you. Again, sometimes I don't really like the word, the suffix client, because in many contexts people overuse it and it's difficult to understand what this stands for. But again, many often you will see HTTP repository or client. For example, if you're dealing with Microsoft services, you will see the word client, but if you search for such an official pattern, there isn't. But it's basically just a repo containing all of those wrapping methods. So we have those model classes. They're in a folder called model, especially when we're dealing with web API calls. Sometimes these model classes are called data transfer objects, or DTO. And I will show you a version that doesn't provide a base class. And later we're going to improve it instead of copy pasting the code for each of the endpoints. I will create a base class here, HTTP repository. In a minute I'm going to show you, but let's review the artist repository. As I said, we are exposing all of the CRUD operations, creation, deletion, update of data. We use the REST client, which comes from the 𝑟est-sharp NuGet package. We are initializing the REST client inside the constructor, and also here we specify the endpoint. So if we want to get all of the artists, all of the artists or the customers, here I made a mistake, this should be an artist. We need 𝑟est-sharp is very simple to use. Every time we need to create a request, REST request, mentioning the endpoint and what is the type of the request. We have all the types of the requests here. In this case, we're making get, and we have a method called execute, where it's a generic method where here in the angle brackets we need to specify to what our body of the response will be deserialized. This means when the body of the response will be this particular similar JSON array, and we instruct the res_sharp to it will deserialize it or convert this JSON and populate, and it will convert it basically to list of artists. And we can access this list of artists using the data property. Similarly, we will have _get_by_id. We will just need to provide the ID, and as you can see, instead of directly calling just the artist endpoint, we need to specify here. We use this convention where we need to slash and provide the ID. Again, here we need to specify that we want an artist instead of a customer because we have another class here. Again, we specify get. This time for the post, this is interesting because we need to create an artist. This means that we already populated the data here in the artist model. It's just a simple entity where it has an ID and a name. Since the ID will be populated automatically by the database, we just need to specify here the name. And in the response you will have the ID. But instead of get, here we have a post. And the only difference here in the post and the put request is that here we need to add the artist as a JSON body. And here the magic is happening where this library, the res_sharp, will automatically convert the artist class to a JSON for you and populate it into the body. We have a similar method for the update. We just need here to provide the ID as well. And we have delete. We have a similar class, but for the client, for the customer. We have get all. Again, just the endpoint here is different, but all of the methods repeated are the same. Just instead of artist, here we used artist. Instead of artist, we used customers. Sorry. Of course, we don't want for all of the repositories to copy paste the code, right? And this is why I created here a base class for all of those repositories, containing basically moving here all of the CRUD operations. This is why I made this generic class called HTTP repository. Again, you can use the word client if you wish. It's up to you, HTTP client or HTTP API web client, as you wish. So it's an abstract class. It's a generic, meaning T-entity, which stands for a class that a simple model class here. We have a protected variable to the client, and I moved here. You just need to replace the T-entity with some of the model classes later when we derive from this class. Basically, all of the rest of the methods are similar to the ones that we already reviewed. We have get_by_id, get all. We have create. But instead of having artist or customer, we use the generic T-entity here. And now, how we use it. This is very interesting. Here is how we define the artist repository now. We are deriving from the base HTTP repository, and I just specified here, replace the generic parameter with the artist model, right? And since this abstract class has a base constructor, the base constructor requires the URL and the endpoint, and I am providing here the endpoint here, which is the artists. Additionally, since as you saw in the front end, for the artist we have a similar search functionality. Here, and we have an endpoint for that, which is search. I added this additional method here,
that it's called search by name, which is returning list of artists, and we're just providing the name. It's just a GET request. Let's review where is that. I think, yeah, here it is. We're just making a GET request to this endpoint here, that it will make this particular SQL request on the backend. Similarly for the customer, here it is. We are deriving from the HTTP repository, but instead of using the artist model, now I use customer. Again, we change the endpoint to customers, and I have a similar search functionality here with this more complex, sophisticated search that can combine and, or, and nor. But in reality is very similar. I haven't moved it to the base class because we have other more simpler repositories where I don't have additional methods, right? For example, for tracks, I provided just the endpoint and we have just CRUD operations. Similarly for the albums, we just change the endpoint, we change the model, that's it. But now when I use the album repository, I have all of the CRUD operations isolated. And if we want to see how if I need to tell you how we can do some web API tests, I move them here to this customers web API tests. This is an NUnit test class. It's annotated with this test fixture attribute. The setup method is a method that it's executed before each test. Each test is marked with this test attribute. And before each test, we are initializing our customer repository, where as a constant, I moved here this base API URL, which is our local host. You can change it with your specific URL. But yeah, every time we have the customer repository. You will notice that something new, I have here this customer factory. So the customer factory, as you can guess, let's open it. This is the factory design pattern. So let's discuss it. A factory, as you can guess from the name, is an object for creating other objects. This is simple factory. In simple factory pattern, we have a factory class which has a method that returns different types of objects based on a given input. For example, here the input can be the email. We can change the email, the first name, the last name. The simple factory isn't formally a design pattern by the classic definition as per the 𝐏𝐻𝐿𝐴 4 book. Instead, it's more of a programming idiom or a design technique. A simple factory encapsulates the object's creation process into a single method or a few methods, often in a single class like this one, this type of utility class. Many often these methods can be marked as static because you don't have a state. The key here is that the factory itself is not meant to be subclassed or extended to change the behavior of the object creation process. There are two official factory design patterns that are out of the scope of this video because many often probably you won't need to use them in such contexts. The one of them is called factory method pattern, which defines an interface for creating an object and leaves the choice of its types to the subclasses for creating a sort of a template for object creation. And also you have the abstract factory, which sometimes is called factory of factories, which is used to create the families of related dependent objects. You can search for them if you're interested to learn more. And this pattern delegates the responsibility of initializing a class from the client to a particular factory class. This we can reuse the creation. And in this customer factory class, it simplifies the creation of customers instances by encapsulating the object creational logic in this single location. If we need to add more, we can do it here. It ensures consistency and reusability across the application and across our tests. It utilizes this faker library to automatically populate these instances with fake or this data particularly useful in testing environments where generate realistic data quickly and efficiently, which is crucial for validating application behavior without the need for real database records, which will be later initialized. But employing this faker library within our factories can enable us to create comprehensive test data sets with minimal effort. And as you can see, I utilized here the default parameters in C#. Later I can change them if I want. I can also generate more than one customer if I wish. Or I can, instead of using faker, I can use, for example, random library. But again, why to do that instead of using faker? Or you can use utility classes like this timestamp builder for generating unique text. Some people prefer that. In some instances I prefer this data time approach, which can generate unique strings or unique URLs. Sometimes this is better, it's up to you. You can reuse that. But yeah, if we return to our tests, what we do here, we are creating a customer object pre-filled with this automatically generated fake data. Then we pass this fake customer to our customer repository. If I open this create method, as you can see, we're inside our base class, the HTTP repository or HTTP client, where we are going to do a post request, providing and deserializing the entity to JSON to the body. Then we are going to execute the post request, and then it will be deserialized back to C#. And after that, we can check whether it was successfully created into the database. Maybe you can check the response, or you can do a GET request by ID. And then, of course, every time we need to clean our test data. This is why I'm calling the delete. Something more interesting here in the test is how we test the search. Here I created with the repository and the factory together two customers with different names and similar emails. And then in the act phase, as you know, we have this AAA pattern arrange act assert. In the act phase, we are calling the search method that is part of the child class, using this query here, 𝑣𝒏𝒕𝒐𝒏 with OR, and then we can assert that we have two results. We can check the results as well, or we can use NOR to see whether this works or not. We can check with link whether this is okay or not. And now if we want, we can use those repositories and factories in our UI tests, which will create a more sophisticated, more reliable test called system test. For example, if we want to create UI tests for this particular search here and check it out, whether it works or not, we can do the following. We are going to open this page in WebDriver. We're going to find the search input. We're going to search them, and then later in my test, as you'll see, we are finding first these headers. By the header, I'm finding the index of the column, because you don't know how they are going to be displayed. And then we're creating every time a unique XPath to get all of the records here to check that really the search is working or not. So let's just quickly review. You can find those tests here in the music shop tests. Again, in the test init, which will be executed before each test, we are initializing the customer repository. We're driving the proper driver with the WebDriver manager. We are starting Chrome. We are navigating to the URL of our demo app, and we are going to close it after the test has been executed. So we are creating two customers again with the was name though. As you can see here, my factory is very flexible, utilizing those default parameters. Then we are finding the customers tab, we're clicking on it. As I said, we are finding the search customer query input. We're typing the search query here with the end. Then I'm clicking the search button. And the interesting part is where, as I said, we're finding all of the headers with a little bit of a more complex XPath, selecting just the text. And basically, if I execute the test, this will tell me that, for example, the index of the header for the first name is 2, this will be 3, this will be 12. Based on the number of the header, I can select all of the MLs and all of the names. Let's debug it and let's see what will happen. As you can see here, we're combining the UI testing and the web APIs and the creation of the data, which is awesome, which makes our test much more stable, because we are creating the data for our test every time and then we are deleting them in the end of the test during the cleanup phase here. Maybe it will be even better if you wrap this in a try catch finally. As you can see here, we have all of the MLs. The index of the ML header is 12. And if I take, for example, this particular XPath, as you can see here, the search is working. We inserted the data. If I inspect it and if I change it to 12, here I will just replace it here with 12. As you will see, with 12, we're just finding just those emails, and I can later check that really the search is working, right? It's working correctly. I'm going to check that in all was names are containing the word though, and that all of the emails are ending with the suffix .com, and then we're going to delete the data. That's all. So if we return here, so the repository is very useful pattern. As we discussed, the repository is widely used design pattern, abstracting how objects are stored, retrieved, manipulated from databases is very useful in automated testing, making our tests much more stable. It's up to you whether you call this HTTP repository or a client. Most of the time we're using it together with these simple factories or more sophisticated builders and factories to create the data. We use libraries such as Faker to populate easily the data inside these model classes, but this makes our test much more maintainable and isolated, because we are creating all the data before interacting with in the UI or with the web API, and then we are deleting it. So in the next module out of our course, we are going to discuss the data-driven testing pattern, where we will reuse a single test body. Instead of copy-pasting a test with different data, we'll use a single test with different data executed multiple times. It will be very interesting, so check it out later. If you haven't subscribed to the channel, please do so. If you have any questions, put them in the comments below. Check the Lambda test blog about many awesome articles about best practices and automated testing. And if you haven't get your free certification about JUnit, NUnit, Selenium and other technologies, check the certification program of Lambda test. Thank you and see you in the other modules. Hi guys, greetings from Bulgaria. In today's video we're going to discuss the data-driven testing pattern, part of our video course about design patterns in automated testing. So until now we have already covered 7 design patterns. In the first module out of our course we discussed adapter design pattern for improving some of the interfaces like 𝐊𝒏𝒕𝒐𝒏, 𝐊𝒏𝒕𝒐𝒏. We added some new functionality and made our test much more maintainable and readable. Next, in the second module we discussed the Decorator design pattern, helping us to bring extensibility to our mini test framework. After that we covered the Singleton design pattern, that it's very popular when you want to improve the API usability of your test library. It works together with other design patterns such as page object model, factory, builders, repositories and others. Next we covered dependency injection, that it's very useful in a little bit more complex scenarios like test automation frameworks. After that we discussed troubleshooting features, working with the chain of responsibility design pattern, and we covered strategy that can help us to add new functionality such as new ways for how we can find elements or new weight strategies. And in the last module we covered the repository and factory design patterns that are essential for the test data management. The HTTP repository basically wraps the database or works as a client for our API for CRUD operations and adding new data to facilitate our automated tests. And as I said, in this module we're going to cover the data-driven testing pattern. In a minute we're going to start, but before that hit the subscribe button if you haven't already, so that you get notified when new videos are published each week on the Awesome Lambda Test YouTube channel. Also check the Lambda Test blog, where there are many awesome articles covering the best practices in the industry about automated testing. Also, in the links below you will find the full source code. I suggest to play along, clone it and check it out. You will find also jump links if you don't want to hear the beginning of the video or some of the explanations. You can directly jump to the section that you're interested in, and also you can increase or decrease the speed of the video. And you will find many useful resources there, like articles and other related videos. So let's get started. First we're going to discuss why you need to care about a data-driven pattern. We are going to use the Lambda Test Playground as always. Here is very applicable. We are going to see in action automated tests for the shopping cart. Then we're going to discuss in more detail the data-driven pattern, especially using test frameworks such as NUnit, but this is applicable for other unit testing frameworks like MS-Test XUnit, or if you use Java for TestNG and JUnit. After that we're going to see the refactor tests, but using the data-driven pattern in tests. So let's get started. First I want to show you the scenario that we're going to automate. As I said, as always, we use the Lambda Test Playground. I'm not going to write any code, but again, directly you can clone the repo. So in this particular instance, we're going to focus more. You will have specific test cases for the products, for the search, for the results. Here we're not interested in that, but instead we're going to jump directly to the checkout page. Here again, for this specific page, we can utilize the same pattern and the same practices that we are going to discuss, but there are many more test cases that we need to write here, like increasing the quantity, update, delete, using coupons, volume discounts, many others. But again, we'll just directly jump to the checkout. So for the checkout, we will focus on one of the happy paths where we are registering a new account. But this is not the main focus. The main focus is that for every operation here, the most important part here is to verify the data and especially the prices, what you're going to bill the client. Again, there are many variations and hundreds of test cases here just for the prices. However, we need to focus more on this taxes feature. This is your new requirement for checking the sales tax, the VAT tax, and especially in this episode we're going to discuss more the VAT tax. For those of you who are not familiar with what VAT stands for, this is value added tax, which is widely used in Europe. Each Europe country has a different VAT tax. Here is this website. So as you can see on the map of Europe, each country, for example, France has a VAT tax of 20, Romania has a 19%, Poland has 23, etc. So we need to verify those taxes. This means that if you increase the quantity here or update delete items, these taxes need to be pre-calculated. They need to be calculated again. And this tax is applied on the subtotal, and after we actually, maybe there is a bug here. Usually if you have discounts like coupons, etc., they need to be after the taxes. So this means that when you change the country, you know, the VAT tax will be pre-calculated. We are going to create a UI test for that. Again, a note here. It depends how your system works behind the scenes. If you have an endpoint web API that is responsible for making all of those calculations, maybe the best place to put most of the tests is actually on an API level, web API, right? Or writing unit tests. Sometimes this is not possible, since many popular front-end shopping carts, they're actually using third-party providers such as PayPal, CyberSource, and others. Basically they're directly in the front end using the JavaScripts, using asynchronous JavaScript to make all of the calculations. This means that the only way you can verify all of the bindings, all of the refreshes of the prices is to check them here, and on top of that probably you will need web API tests again. So here in the solution, again, this is a simple NUnit project containing WebDriver tests. In this project, if you're not familiar with NUnit, I suggest to check the Lambda test videos about NUnit. There is a whole series. But in short, NUnit is a very popular unit testing framework. We're going to cover some of its features later on when we discuss the data-driven testing pattern. And in order to use it, you can use the predefined projects. When you click New Project, there is a version of NUnit, or you can directly install the NUnit dependencies here. You need this for NuGet packages. And on top of that, I installed all of the related Selenium projects, dependencies. In the .NET world, we use NuGet. In Java, you probably use Gradle or Maven. And I installed some for backward compatibility like WebDriver Manager, but if you use 4.11 and above, you just install the latest Selenium and it will download the driver itself. So before we look into the, again, I won't couple this particular video with the other patterns that we use, because I want to keep the things simple. However, in NUnit, we put our tests in a test class annotated with this attribute test fixture. And in the setup phase, this is the method that will be executed before each test. We initialize the driver. Again, for backward compatibility, we use the WebDriver Manager, which will detect which version of the browser you have, for example Chrome, and it will download the proper driver. The driver is responsible, you know, your code is communicating with the driver communicates with the browser. Again, if you use 4.11 of Selenium, now the newest versions, they use the so-called Selenium Manager, which is doing that automatically for you. So here, later on in the video, if you don't want to execute your tests on your local machine but in the cloud, here this will be the place where we are going to put all of the Lambda test capabilities, for example. Again, there will be demo about that. After each test, we close the session in the browser. And as you can see here, I have variations as a comment of all of the important test cases that I need to automate here for checking all of those VAT percentages and the calculations. For each country, I'm selecting one of the test cases to select one product, and then to have one more test that basically added 9 of those items. Of course, there are many other cases, like as I said, updating, removing, adding 2 products, coupling this with discounts. Again, let's keep it simple. But again, the first thing here is the quantity, then the country, then the expected VAT percentage, which is 2021 or more. The expected VAT tax, this is the actual tax. As you can see, for one product is 33, and then just multiply it by 9 and you will find the expected VAT tax for 9 items. And this is the total. Again, the total can be different depending on other discounts and taxes as well. Again, we are keeping it simple, just discussing the VAT tax, because there are other taxes as well for other continents and countries outside of Europe, like sales tax for India or United States or Canada, but their calculations are much more complicated. So, as you can guess from the name, here my name is Check the VAT displayed when we pick Croatia for the billing, and the quantity is 9. So the first thing that I change here is the quantity of 9. If I need to explain really quickly my structure here, we use the page object design pattern, very popular design pattern in automated testing. We basically discuss it in each of the modules. But in short, what is it? We have a class that holds all of the elements with their locators, all of the actions that we are going to do on the page. Many often we use model classes, as we will refresh in a minute. Instead of providing 6 or 7 parameters, we provide a single class holding all of the input parameters. And sometimes in some implementations we can put the assertions as well, especially if they are more complex or require additional operations there. And so here are our pages. We have one base class here holding references to the iWebDriver, WebDriver, weight, and the actions. And all of those pages here, they basically derive from this base page called the base constructor. As I said, we are waiting for most of the elements here to be visible, to exist. And we have all the actions. The interesting part lies here in the checkout page, where we have most of the elements. Again, for now, let's not focus on the actual, there are many other videos regarding how to write locators and such. But yeah, we have all of the elements first, then we have all of the actions. As I said, we prefer to have bigger methods that are grouping the actions, which defines the so-called DSL or domain-specific language, making our test much more readable, because you see the range phase, the data, and then just the actions, and we are hiding all of the details here. So we have few user input, few billing address, and we have some assertions. The 3 important assertions are assert total, assert VAT percentage, and the VAT tax. Sometimes you can put here some exception messages to make the troubleshooting easier. You can check one of the previous modules regarding the chain of responsibility. There we covered in much detail the troubleshooting techniques. But yeah, if you have to do some calculations, because right now we hard-coded some of the prices here, sometimes it's good practice, especially in such complex scenarios, where here, as I said, here we can have much more items and prices, like volume discount, coupon, which is a percentages coupon, or amount coupon that can be just applied for one of the products and not for 2 of them. So instead of hard-coding all of those prices, we can have a separate class responsible for calculating the expected results. It will be up to you. This is like architectural decision. But if you do that, maybe it's not suggested to put this logic directly in the page object, but instead you will have additional service class for that, like a calculator service. That you can later use in the range phase. As I said, we use those model classes that are grouping the input or output validation models. One model is just the so-called POC object, which contains just string or integer properties, a simple object, no actions there. So we are grouping, and here I changed, because this is my case, I changed here the quantity to 9, and then I changed the country to Croatia. The another change here when I use the page object lies in these three methods. I changed the VAT tax to 25, then I have the assertions for the VAT tax to this particular amount, and I change the total. Again, if I need to apply and write the second test case, the most dummy approach is to copy paste the whole method, like I did here. I updated the title for quantity 1. I continue to have Croatia. So I updated just the quantity here. The country stays the same, and then I updated these two prices. Now the VAT tax is lower than the first example with the 9, and of course the total is different. I did the same for Belgium, for quantity 9. We keep the quantity 9, then we have Belgium here, and again we copy pasted, and then we change here the VAT tax, pre-calculated and hard-coded everything. And I repeated that for a couple of more countries. You will notice when you clone the code that I actually made a mistake on purpose, because when you copy paste, it's a common mistake to mistake something and to forget to do it. Like here, on purpose again, I have Austria for quantity 9, and mistakenly I put here 1. I forgot to update it to 9. Probably this test will fail. Now, as you can guess, this is not the best and suggested approach, because we copy pasted a couple of times the same test. If you need to make even a single refactoring, applying and adding a new parameter to a particular method, or change the signature or something, especially with the parameters, this is a problem. Or if you need to add an additional step, you will need to go to many tests and update it manually, which is not suggested. Copy paste, as you know, it's always you need to avoid it. Another technique, very simple, instead of directly copy pasting, is just to refactor and extract the method to a private method here. So I extracted the core logic of my test, if we accept that it always stays the same, and I added parameters only for the variable things here, like the quantity, the country, the VAT tax percentage, the expected VAT, and the expected checkout total. So now I changed them here, like the parameter, as I said. We have the parameters for the tax, expected, and the expected total. This is like a workable solution, and I use the private method here everywhere. This is much better than just copy pasting. However, if you need to understand what's happening inside the test, you will need to go to its implementation by clicking Control and left click of the mouse. Then I will need to check again, and then I will have to return. Depending on the size of your file, this back and forth sometimes takes longer, and especially if you have more than one file, then you need to move this method to a base class or to another facade or similar class, which again, this back and forth is making the troubleshooting and understanding slower. Instead of doing that, there is now is the time to discuss the data-driven testing. What is the data-driven testing actually? This is a software testing pattern that involves separating the test logic, like here under this folder, data-driven. In a minute we are going to cover what this means, but basically I separated the logic from the data. So this involves separating the test logic from the test data. It allows the engineers to run series of the tests using the same test set of instructions or the code, like I did here, but with different inputs and expected results. Different inputs and different validations, right? This approach enables comprehensive testing of application functionalities under various conditions without writing multiple test cases for each possible set of inputs and copy pasting like we saw. And what are the benefits? The first most common one is, separation of data and the logic. The core principle of data-driven testing is to keep the data, the test data, the inputs and the expected outputs separate from the test script, from the logic. This separation makes the tests easier to maintain and extend later. We can also use external data sources, as we are going to see in a minute, like this type of CSVs. Test data can be stored in these external sources, databases, spreadsheets, XMLs, JSON files, or this type of CSVs. This makes it easier to modify the test data without altering the test code. We can use parameters, basically some tests like unit testing frameworks as unit accept our test to accept parameters. The same test logic is executed multiple times with different set of input data and expected outcomes of these external data sources. And adding new test scenarios can often be as simple as adding new raw data to this external source like this CSV, right? This data-driven testing allows for extensive test coverage with fewer test scripts and can significantly reduce the amount of code needed for testing and can help automate repetitive test scenarios. So, NUnit, this can be done, as I said, with NUnit, MS-Test XUnit. We're going to cover NUnit because it's the most used in the .NET world. Again, you have the same capabilities for Java, for JUnit and TestNG. There are other videos that I recorded for JUnit describing that. So, NUnit is a popular C# testing framework from version 2.5, offers support for these parameterized tests. It contains various NUnit attributes. We are going to cover most of them, or the most important ones for automated tests. So the first one, and my favorite, is the test case attribute that marks a method, like here, this method. We don't need those spaces. So we use it instead of the test attribute. So it annotates a test method. It also provides the inline data that needs to be used when that particular method is invoked. It can appear on one or more times on a test method. It doesn't make sense to just put one test case attribute. Probably you'll have more because you need, to apply the data-driven testing approach. And with each appearance carrying values for the test case. What else? This attribute helps in supports several additional named parameters like author, category, description, expected result, test name. You can also, when you use this approach with the data-driven, you can put like this attribute, special attribute, parallelizable, parallel scope all, and this will execute depending on the scope all of your tests in parallel. This is excellent when you combine it with the power of Lambda test and execute it into the cloud. But you need to be careful. If you use this approach, probably you will need to wrap the iWebDriver in this thread local container, which will basically isolate each instance of the WebDriver between the different processes. There are separate videos about that, especially when we covered XUnit. There is a dedicated video about that. So this is the first attribute, and it's very important to, as you can see here, we have the inline data. We have 5 parameters, and you need to make sure that you have the exact amount and the right type of the data. We have the quantity, we have the country, a string, but the default percentage is actually double. And NUnit is responsible for mapping the actual type of the parameters, right? It will going to parse it, to number, etc. but for example, if you provide here that this is double, and if you have the sign here, this will fail. And if the parameters doesn't match, then there will be a failure. So this is the first type of attribute. It's very easy. We are using the same body, but for all of this test data. Now, another very popular attribute is the test case source. This test case source attribute can be applied to any test method, just like the test case attribute. The property methods or fields specified by the test case attribute provide the arguments to the parameterized test. Unlike test case attribute that is used to provide simple compile time constants as parameters to the function, the test case source attribute can be used to provide more complicated parameter types. Another major advantage of this attribute is that the source method is reusable across different tests. The object data that it's part of the method using the test case source attribute can also be reused multiple tests. If we open this CSV data source, as you can see, this is a simple class. It provides one static method that needs to return 𝑖𝑛umberable. So the source specified by the attribute can be either return 𝑖𝑛umberable or a type that implements 𝑖𝑛umberable, like list. For simple tests, object array is fine, can be returned from the source. For more complicated tests, 𝑖𝑛umberable is used as the test case data. Another thing that it's very important to note, since we are returning 𝑖𝑛umberable, we need to use the yield return operator, which can speed up and is used for each statements. This means that if you break, we won't go over each of the cases. And here, the thing that I did here in this CSV data source is that we read and extract the data from the CSV source. There are other more simplistic approaches. There are some NuGet packages for doing that, but I used directly C# code like Stream Reader and CSV Reader. And here it's important to mention the name of the method, part of the data source that needs to be used. And besides that, after that, we're just again have similarly the number of parameters that are required, and we're using the body. That's everything that we need to know. Another thing, part of the, by the way, you can check it in the resources below this awesome article and unit tutorial for data-driven tests with NUnit. I basically got the code from this value source. Value source attribute, as you can see, it can be provided inline for different parameters for the test method. It's very similar to the test case source, except that it's used as a method parameter. And using this value source attribute for creating parameterized tests in NUnit is especially useful for cross-browser testing, as in this example. As you can see, we defined these private static arrays of strings like browsers, browser versions, and operating systems, and author here make that code execute multiple times like combinations for cross-browser testing in the Lambda Test Cloud. I prefer another approach to solve this problem. You will find here another class called Product Purchase Tests Cloud. And I wanted to execute all of my tests in the Lambda Test Cloud because this is very important for front-end tests to be checked against multiple browsers, multiple browser versions, and operating systems. Lambda Test Cloud is excellent for that as an infrastructure provider. They provide all of those browser and browser versions. You can use the capabilities generator. You need to pick your language. For us, we need C#, we need NUnit, and we need to pick the browser version, right? But as I said, for example, if you're testing a banking software, then you need as a compliance to check it against multiple browsers and browser versions and to be sure that everything is working correctly. So here we need to provide the browser version, the operating system, and depending on the options we will trigger the browser. And we can use the test fixture actually to provide and multiply all of the tests in this class and execute it against these different options. This is a very popular approach. So this test fixture and unit attribute again annotates a class that contains tests, but we can provide multiple parameters to it since it provides a generic version of the attribute that was introduced in version NUnit 2.5. And so we can provide these arguments here. I initialize them in the constructor of this class, and later during the setup phase I have a switch. Of course, we can use adapter or similar factory method approach for moving this initialization logic. I wanted to keep it simple. But if you use additional classes, you will just provide the parameters to those methods. However, we extracted the the username and the access key to the environmental variables. We get them here. We initialize the dynamically the options based on what we have in the attribute, and then again depending on the version and the operating system, we are multiplying those tests. And if I already rebuilt the project, one key benefit of NUnit is that if we open now here in the test explorer, you will see that for every test, of course these are the copy-pasted tests, we don't care about them, but actually about the CSV, you will notice that NUnit, and based on the attribute that we have, multiplied our tests based on each row in the CSV and generated a unique test for us. The same happened for the test case attribute now. As you can see, we have a very good name with the quantity one, Cyprus, something, and all of the prices, which is excellent because this is not supported in all of the unit testing frameworks across multiple programming languages. But this is a big benefit because you can now directly debug this particular test, especially even if it's in a CSV. I prefer test case attribute when it's possible instead of using CSVs, because this makes readability of our test much clearer instead of going directly to this file and guess what's our case here. But it's a matter of choice. Yeah, this was everything that I wanted to show you in this particular video. Next, we are going to discuss the builder design pattern. So we covered, again, don't do the copy pasting when you have multiple test data. Maybe it's better to move it to private method, but instead use the power of your unit testing frameworks, use the data-driven testing pattern to make your test much more maintainable and readable. I prefer test fixture approach and the test case attributes in NUnit. You can even combine them. Yeah. So thank you for watching. Check the Lambda test blog for many awesome articles about best practices in automated testing. If you have any questions, put them in the comments below. I'll be really happy to hear if you have wishes about other design patterns to be covered in this course. Also, follow us and get your free certifications about NUnit, JUnit, Selenium, and other important technologies. Thank you for watching. Hi guys, greetings from Bulgaria. I am Anton, and in this video we are going to cover the builder design pattern, part of our course about design patterns in automated testing. What we covered so far. First, we discussed the proxy and adapter design patterns, where we improved significantly the iWebDriver and the iWebElement interfaces. We added new methods and made our tests more readable and more maintainable. In the second module out of this course, we covered the Decorator design pattern, where we use it to add flexibility and extensibility to our mini test framework. Then we cover the singleton. Singletons are quite useful, making our code more usable, improving the API usability. It can be used together with other patterns such as factories, repositories, builders, page object models, and others. Then we cover the dependency injection, which is quite useful in building sophisticated test automation frameworks. We cover the chain of responsibility, and we use it to bring troubleshooting features to our mini test library. Also, we applied the strategy design pattern for adding flexibility to our mini test framework, for adding new wait and find strategies. Last but not least, very fundamental video about test data management, where we covered repository and factory. Please check it, because we are going to upgrade this particular solution in the current topic about the builder design pattern, but I will give you a quick refresh on the topic, even if you haven't watched the previous module. And in the data-driven testing pattern module, we covered these modern unit testing frameworks that give you the flexibility for using data-driven approach, for not copy-pasting all of the tests, but we can reuse them using attributes, annotations. We can provide test data via Excel sheets, etc. It's quite useful. So, if you haven't subscribed to the channel, please do so. Hit the ring bell so that you get notified when each week a new video is published on the Lambda Test YouTube channel. Also check the Lambda Test blog, where modern best practices about test automation are discussed in many details. In the links below, you are going to find the source code for all of the demos that I'm going to present. I suggest to clone the repo, and play along with the video. Also, you will find there the demo application that I'm going to use in our examples. I'm going to explain it shortly. Also, you will find related resources and jump links to the different parts of the video. And of course, you can modify the speed. If it's too slow for you, you can speed up or lower the tempo. So let's get started. In this particular module, we are going to cover the builder, but as I said, first we're going to see the previous solution that we use for test data management, because now we are going to upgrade it using the builder. So I'm going to present the demo app and really quickly give you an overview again about the repository and factory. If you already watched the video about that, you can jump directly to the action where we implement the builder. Then we are going to discuss, of course, the simple version of the builder, and then we are going to use it in our tests in a much more real-world example. So let's get started. First, my demo application is built on top of this tutorial about SQLite tutorial, where this website provided this database about a music shop. And this music shop is a database where we have customers, we have responsible employee for each customer. Each customer can buy tracks or albums that are recorded by an artist, and those tracks are grouped into playlists and from different genres. So I created the following front end for that. It's very simple. Basically, I exposed through the UI all of the operations that we can do against this database. We can search for an artist, we can update the artist, we can delete it, we can show all of its albums, and we can view all the tracks part of one of the albums and the different prices and sizes. Also, we can add an artist, we can check all of the customers. This is more sophisticated, as you can see. We have in the previous module about the factories and the repositories, we tested and created tests for this more sophisticated filter here with and or nor, because there are some bugs, of course. Also, you can add a customer here. There are some front-end validations, and as you can see here, we have all of the CRUD operations, but also we can see all of the invoices for the customer, all of the invoice items related to the particular invoice, view of the responsible employees, and that's it. You can, as I said, clone this particular application. From this, you will find the link in the description below, this music shop frontend, simple name. This is Node.js application, so when you clone the repo, the only thing that you need to do, navigate to the folder of the repo and call node server.js, and then everything starts. Of course, you need to install Node.js, that's the only requirement. And really quickly, if I need to explain the demo project itself, I try to make it as simple as possible. There are only two important files, index.html, of course, as you can guess, here is the whole front end. I used here Bootstrap, inline CSS instead of have a separate CSS file, and also at the bottom we have a lot of JavaScript in a script tag where we call the backend, the web API, to fetch the data and update the front end. And of course the backend is placed in this server.js where we have Node.js code for declaring the different API endpoints. Yeah, I use JavaScript to write queries against the database and return them in a JSON format. So besides the front end, as I said, for example, here we have an API customer that returns all of the customers, right? Or I can get in the form of a JSON. And then if I type here the ID of a particular customer, we can return just one of them. And I did that for all the tables. And also we have additional endpoints for writing the search queries, etc. So we are going to use these endpoints in our tests to create the test data for the front end, or if you need to write additional tests for the API tests. Now, in my tests, I use a library called 𝑨𝒏𝒕𝒐𝒏. In a minute, I'm going to show you how I installed it and set it up. This is their website. This is the most popular library for making web requests in C#, and we use it for testing as well. The usage is straightforward. We just install this NuGet package dependency called 𝑨𝒏𝒕𝒐𝒏. After that, we add the two usings here, and the main thing that you need to use is this object called REST client. If we have additional options, we place them here, initializing this REST client options object and provide it to the constructor. And after that, it's very straightforward how we use it. We construct a REST request object and we provide it to the different methods like get, put, post, delete, etc. Most of the time this is used as asynchronous code. This is why you need to use the await keyword. But if you wish, there are other overloads for the methods that are not asynchronous. Or you can place .result or getAwaiter, and this will work. The other main thing about the 𝑨𝒏𝒕𝒐𝒏 is that instead of dealing with directly with these JSON objects and parsing them, etc., nobody does that now. Instead, this JSON is serialized and deserialized to C# classes. We call these classes models. In a minute I'm going to show them to you, but we work directly with properties and methods instead of working with text and JSON. You can check the 𝑨𝒏𝒕𝒐𝒏 or the previous video where I discussed in more details. Now, this is our sample project. In our sample project, first let me show you what is the setup. I installed a few NuGet packages. We have all of the standard NUnit dependencies here. If you're not familiar with NUnit, check the links below. You will find a whole course on the Lambda Test YouTube channel about NUnit, maybe the most popular unit testing framework in C#. As I said, I installed 𝑨𝒏𝒕𝒐𝒏, and from the front end you can use no matter WebDriver, Playwright, it doesn't matter. I use here WebDriver since it's the most popular. And I installed also a few other NuGet packages needed for the Selenium for backward compatibility, for example, the WebDriver Manager. But if you use version 4.11 and above, you know, the management for the drivers and the browsers is now coming out of the box, instead of you don't need these dependencies anymore. And also we need one more library that I'm going to explain in a minute. It's called Bogos. We use it to create fake data in our factories. That's basically it. And as I said, for example, for the customers that I showed you, we have those model classes. This is why they are placed inside a folder called models. For each of those endpoints, like customers, albums, etc., we have such simple classes where each node here, like city, is represented by one string property, integer property, or boolean property, right? Very simple. And actually Visual Studio can generate that for you if you don't have them. There are other tools as well, but if you go here and go to edit, paste special, paste JSON as classes, basically Visual Studio will generate this model class automatically for you. Maybe you will need to modify it a little bit. For example, for nulls, it doesn't know what is the type, so you will have to manually update it to string, and maybe you know, change the name afterwards. But it's very straightforward. There are other online websites for doing the same, but I don't suggest using them, especially for production code, since you don't know, you know, who owns the servers and the websites and where your data will go. So I always check if I install extensions whether they do web calls or not before using them. But I suggest to use directly this built-in capability in Visual Studio. If you are working with Java, there is a similar functionality in IntelliJ. So yeah, I generated all of those model classes for us, and then we have different repositories. What is the repository? The repository, as you can see here, it gives us flexibility to do all of those CRUD operations, like let them collapse all of them. As you can see, we have get by ID, get all. We can create an object, we can update it, we can delete it. So in short, the repository design pattern is widely used design pattern that abstracts the way objects are stored, retrieved, and manipulated from the database in an application. It acts as a middle layer between the business logic and the data mapping layer, effectively hiding the details of data access, you know, the data access mechanisms. The pattern is particularly useful in applications with complex domain models, and it enables developers to work with more object-oriented view of the data like these models. And calling your wrapper an HTTP repository can be appropriate if your wrapper is designed to abstract the complexities of this HTTP communication while presenting a simple interface for performing CRUD operations like I'm doing right now on the entities, and as if they were being directly managed in a local store, right? This naming aligns well with the repository pattern's goals. This is why I use this particular word. However, on the other hand, naming it a client, this is again widely used, is also suitable, especially if the wrapper's functionality encompasses more than just CRUD operations, including actions that are specifically to consumptions of a particular RESTful service. The term client broadly indicates that an entity that consumes service provided by another system or a component, which in this scenario is a RESTful API. Here, as I said, in the base class for all of the HTTP repositories or clients, it doesn't matter what word you are going to use, we have this generic class where T entity will be replaced with the actual type of the model. For example, for the customer, we specify here customer. For album, we'll specify here album. And yeah, this is a generic parameter. And inside of each of these CRUD operations, we're just constructing the REST request method that I explained, and we are executing the request. After that, if you want to deserialize your JSON response and get the actual model class, we call the data property. I did the same for getAll. Here the only thing is that now the data is presented in a list of T entities, right? For the create, one specific thing is that we need to add this T entity as a body, and the library will automatically deserialize the entity to a JSON and then supply it to the HTTP request. So we have repositories for all of our major endpoints, for artists, for albums. Sometimes, like for the customer, I have a custom endpoint method for the search. This is why I added this new method to the child class that implements the HTTP repository. That's that. And then we have the factories. What are the factories? A factory, for example, for the customer or for the album. A factory is an object for creating other objects, right? At the end of the module, I'm going to explain the difference between this approach with factories and repositories and then with the builder. But for now, let's keep it simple. So a factory is an object for creating other objects. In simple factory pattern like this one, we have factory class, which has a method that returns different types of objects based on a given input. In this case, we return album. The simple factory isn't formally a design pattern by the classic definition as per Ganka 4 design patterns. Instead, it's more of a programming idiom or a design technique. A simple factory encapsulates the object's creation process into a single method, often in a single class. This method decides which class to instantiate and returns an instance of that class. This album factory simplifies the creation of albums, and it ensures consistency, reusability across the application. Also, here we utilize everywhere this bogus library or a faker library to automatically populate these instances with fake data for properties such as album ID, title ID, artist ID. This approach is particularly useful in testing environments where generating realistic data quickly and efficiently is crucial for validating behavior without the need for real database records, right? So here is, for example, the customer. We can generate that, as I said, instead of using bogus, we can use random IDs or first names. But again, bogus will generate a fake real data, real names, real emails, real phones, etc. instead of using this approach. This is why I suggest to use Faker. It uses similar Fluent API or chaining methods that we are going to use in the builders. So yeah, and if we want to use them in tests, I already did that. So here I wanted to create tests for the web API. This is why I in a class with tests, we annotate the class with this test fixture attribute. The setup is called before each test. So here we use the factory to generate the entity. Right now, until here, it doesn't go to the wire. We are not creating anything. In order to create it, delete it, or do something with it, we need to use the repository. This is called separation of concerns. We basically have two different classes dealing with different tasks. One of them is to create the data itself, and the other is how to communicate with the endpoints using the REST sharp. So here, with the customer factory, we created this default fake customer, and then we created it. After that, we assured that it was created successfully, or maybe you can do here get request, and then we delete it at the end. Here we tested the get by ID, as I said, and here we tested the search, where I created two customers, called the search, and then afterwards in the cleanup phase I deleted the customers, etc, etc. If we want to test the front end, of course, the whole point here of having those patterns is that if we need to test the front end using WebDriver or similar library, we want this test data management. We need to prepare the test environment. Many often we have different instances of our web applications on different environments. Thus, we need to prepare the data. And this is exactly what I did here in this music shop tests. I initialized in the setup all the repositories, most of them, and then I wanted to prepare an artist with all of the customers, all of the tracks, all of the albums, all of the invoices and invoice items to it before all of the tests. And now, what we did here. First, we created a default artist using the factory, right? We changed the name. We created the artists using a post request using the repository. Then we assumed that we want to create 2 albums. We generated the albums with generated 2 default albums using the factory for albums. We changed the titles to be unique. We created them with the repository. After that, we assumed that we want 5 tracks. But as you can guess, this is not very flexible because every time I will need to modify the numbers, I will need to modify the names, etc. This is not very good solution, but we are going to improve it using the builder. This is why I'm giving you this example. So we wanted to have 5 tracks per album. This means that I use the factory for tracks, I change the name, I assign the proper album, then I create the track. Then inside the track, assume that 10 customers are going to buy this track. This means that I'm creating the customers, every time unique customer here, based on the IDs, I'm calling the customer repository now to create a post request for the customer. And then for each particular customer, for each purchase, we need to create an invoice with a particular unique date, and then to each invoice we need to assign the different invoice items per all of the tracks. As you can guess, this is very complex setup that we don't want to repeat every time. It's not flexible at all, and it's a very bad practice to put this directly to your tests, because probably you're going to end up with multiplying this, copy pasting it in many places, and this will be really hard to read and maintain over time. It doesn't matter what we do later here, we're going through the UI using the already generated data from above. But yeah, we're going to see another approach using the builders. Let's return to the presentation quickly and let's discuss the builder design pattern. What is the builder? The builder design pattern is a creational pattern that is used to construct a complex object step by step. It separates the construction of a complex object like we did right now with this complex music shop construction. And so yeah, it separates the construction of these complex objects from its representation, allowing the same construction process to create different representations. Like for example, you can modify the number of albums, number of tracks, change the names, etc. This pattern is particularly useful when an object needs to be created with many possible configurations. Like as I said, we may want to create 20 albums or I don't know, 30 tracks per album with totally different names, with totally different number of customers and invoices. So yeah, in C#, the builder pattern typically involves the following components that you can see in the diagram here. We have the builder. This is an abstract interface that defines all of the steps needed to build a particular a part of this complex object. Then we have the concrete builders here at the bottom. They implement the builder interface and provide implementation for the steps defined by the builder. It keeps track of the representation it creates and provide methods for retrieving the final product. There can be several concrete builder classes, each constructing a different representation of a product. And then we have at the top the director, which is responsible for managing the correct sequence of object creation. It accepts a builder object and executes the necessary operations on it. And of course we have the product. This is the album, the customer, the invoice. This is the complex object that it's being built. And the concrete builder builds the product parts, and the product itself is returned by the concrete builder itself. Now let's see a very simple implementation of this pattern here. We have here this car class. We have maybe not make, but this is the name of the car. We have the model, number of doors, engine type, etc. So we have the car director. The car director class acts as the director in the diagram, and the car builder is the concrete builder that constructs the car product. The director can command the builder to produce different types of cars. In our case, this is a sports car and SUV. So, and the director, when it commands, it doesn't know the specific details of each car. This pattern provides flexibility in the properties of the object that can be created and simplifies the construction. And here is the interface that we can provide the names and the model, the numbers, the engine, cars, etc. And then we have the concrete builder, which is the car builder, which now makes this car, which is the name of the car. It sets the model, it sets the number of doors. Of course you can do it with properties instead of these methods, but I want it to be more understandable for people that are coming from the Java world. So we set the engine time, etc., and with the get car we are returning the car itself that was built. And if we return here, as you can see, we are using this iCar builder where we use it. This is how you use it. You provide the actual builder here, and we say, please make a Ferrari, set a model, set a number of doors, the engine type, and then we return the car with this default data. This is a very simplified version of the pattern, right? Now, in our case, we are going to use, you can build simple builders, like here, I created a simple builder for my albums. I created here an empty album, and then we have these modification methods where we can set different album ID, different title, different artist. We can add tracks, and then when we call build, this will return the initialized object. Of course, this is a very simplified version of what we want. Before we go into the details, I want to show you now, in this builder folder, I created all of these interfaces for the builder. As you can see here, we have album builder, which contains all of the modifications that we can do to a particular album. We can say, usually this prefix with is very popular with this pattern, so I suggest to use it, with title. This means that we're going to override the default and have a different title or different tracks, and we can override that. As you can see here, for all of our builders, we have a base interface for that. What we have here in the base interface is that it accepts the artist builder, the concrete builder type, so that we can build this fluent interface or chaining methods. And we have the actual, like with the repositories, we need to provide the actual type, the actual model type. And what we have in the base interface is that we have a method with default configuration. In here, we are going to call our factories to create the default configuration for us. And then we can later use these additional modification methods if we want to have a different small modifications or huge modifications to the default. And when you call build, this will return our directly model, which means the album, the artist, the customer, etc. For all of them, again, I created for the different entities in columns, I created different with methods. Also, since I wanted to have different concrete builders, I created two types of them. One of them is transient and the other type is persistent. What this means? This means that sometimes we want to build such complex objects without persisting them, without saving them into our database, or without calling our repos and calling the web APIs. This is the transient object. Where we use the transient objects? Well, we have in our UI, sometimes you will want to populate here a customer, right? The correct customer with all the data. So we will want to use these transient objects to populate them in some front-end forms. And the persistent, as you can guess from the name, is the one that is very similar to the transient builder, but is going to persist them using the repo and factories together to save them. Now, as you can see, we have two types here. This will be a more complicated builder implementation using factories and repos inside. So you need to be very careful about the separation of concerns. Integrating external system calls directly within builder methods could lead to violation of separation of concern principle. Mixing the logic for object creation with business logic or external services interactions. And to maintain this clean architecture, consider abstracting these external services integrations like we did with the factories and the repos into separate classes or services. The builder can then use these services like we're going to do, keeping its primary focus on object construction. So here is the test data director. Basically, I abstracted here the long chain of initializations that we had before in our test here. Basically, I copied the code from here, but I wanted to use now the builders, right? So here is what we do. In the test data director, we just provide the builder mode, which is persistent or transient. At the bottom, we have different private methods that return the proper builder, whether it's persistent or transient. The two concrete builders, we're getting the right one. If it's persistent, of course, all of these methods are going to return and create the new persistent builders of the same type. So we have implementation of the persistent builder for the invoice items and a transient version. And we have one main method called create artists with discography and sales. And we have some parameters here. We can modify the artist name, how many albums we want, how many tracks per album we want, and how many customers we want. And the thing that we do here is that we get the artist with the default configuration. In a minute I'm going to show you how this works, but basically inside we call our factories. So we create a default artist from the factory, and then we call this with methods to modify the default. As I said, we use the builder to create, we use it in this complex setup where we have many configurations, right? We cannot proceed just with the defaults. So we created an artist with modified name, we build it. Then we have again the for loop, but now instead of calling directly the factories and the repos, we just call the album builder. We modify the title and the artist, just these two modifications. Inside we have many more. We call build. So now we have an album, which if you pick the persistent mode, then this build method inside will call the repo, do the post requests, and create the repo inside the database. And we do the same for the tracks, for the customers, for the invoices, but again the director is the one who knows how to change them, how to call them properly, how to modify the data, etc. He's coordinating, orchestrating the whole process. We are not dealing with that. And now the separate builders, if we look into maybe a more simple version of it, for example, the transient album builder, it derives from this artist builder. We have an artist private variable here. We created an empty version of it. As I said, we needed to implement the main base iBuilder that defines this method with default configuration. Basically, every time here we call this artist factory generate artist. Since we are in the artist builder, in the customer builder, you're going to call the customer factory. So we are getting the default version of the artist, then we are returning this. This is how we implement this chain methods pattern fluent interface. Then again, we do the same for the with artist ID. We are just initializing the artist, the name, the album, etc. And when we call build, we are just returning the private variable that we have here, right? Nothing more. But if you look, there is just a slight difference between the transient and the persistent mode of the builders. Of course, you can have a base class for that. Just for simplicity, I didn't want to make it much more sophisticated. So if we look into the persistent builder, the only difference is now that we use here the artist repository. We use it as a composition. We initialize the repo here. We initialize the artist. When you call with default configuration, now we have a default artist. And if we want to modify something, again, you will call some of the with methods here. But in the end, instead of directly returning the artist, first we are calling the artist repository create, which will make a post request to the API. It will return it, and then actually here, in order to have the proper ID, it should be like that. This will initialize the artist with the proper ID created by the endpoint. Then we are going to return it. But again, we have this fluent interface, chaining the methods, right? And again, we have the same for the customer. For the persistent customer, as you can see here, we have a little bit more complex methods, like with this with address, with a bit more parameters, but the logic is the same. We just modify these modification methods. They just modify the internal customer object that we are going to retrieve, calling the build method at the end. But again, since this is the persistent customer builder, it will call the repo inside. Now, 3 points here. The first is that if you use the action API of Selenium, you will be very familiar with this fluent interface. However, it's very similar because we use both the builder and the WebDriver actions class. They use the fluent interface that allows for these chaining method calls. This makes the code more readable and easier to write. However, there are differences in the outcome. The builder pattern uses this build method typically, which returns a complex object, while the actions class calls this perform method, executes the queued actions without necessarily returning an object. So the builder is primarily about constricting objects, allowing for varying representation of object being built, while the actions class, on the other hand, orchestrates a series of user interactions with a web page. And the focus is on action sequences rather than the object state. There are some popular third-party libraries like 𝑨𝒏𝒕𝒐𝒏. You can install it via this NuGet package. It's very popular in Java. In C# this is its version. Here you can see how it works, but basically it gives you this 𝑨𝒏𝒕𝒐𝒏 represents an effort to bring some of these productivity benefits of the project 𝑨𝒏𝒏 from Java. However, as with any third-party libraries or tools, the basic thing is that here it gives you these with attributes that will automatically implement the builder for you, right? However, you need to be careful with any of these third-party libraries or tools. It's important to carefully evaluate all of the features, documentation, community support, and how it fits in your specific development workflow and project requirements. Always consider the long-term maintenance implications of adding such library to your project, especially for critical or large-scale projects. And now to wrap up, I want to discuss the difference and to compare all of this code that we have now here with the builder and the test data director with the factories and the previous approach. The builder pattern, it allows for constructing an object step by step, explicitly setting each property. This approach is useful when you need precise control over the object's properties or when constructing objects involves complex logic. While the factory, or this, for example, album factory, is best suited for situations where you want just to quickly generate an object without with default or random values. It abstracts the creation logic and is simpler to use for straightforward object creation scenarios. The builder pattern can create different representations of an object by involving different methods in varying orders. We can modify the data. And this flexibility is beneficial when an object has many properties like our music shop, right? That can be optionally configured. The factory method is less flexible in this regard, and as it typically creates an object in one go with limited or no customizations options for the color. Of course, you can create multiple such methods inside the factory classes for the album factory, for example, but I always prefer to create such methods just when I'm going to use them multiple times in multiple places instead in just one test. So use the builder pattern when constructing a complex object with many optional or required fields, especially if some of those fields are complex objects themselves, or if there are multiple representations of an object that might be required. And use the factory method for simpler scenarios, where you need to create instances of the class with standard configurations, particularly when these instances are meant for testing or when specific configurations are not crucial. So we covered a lot of topics. Thank you for watching. Check the Lambda test blog for many awesome articles. Put any questions below in the comments below. Check the Lambda test blog for many best practices. And of course, get your free certification about 𝐀𝐈_UNIT, Selenium, JUnit, and many other technologies. Thank you for watching and see you in the next modules.